Okay, the project for today that I have in mind is to write a Brainfuck compiler. In case you're not familiar, Brainfuck is a highly simplistic programming language. It's about as simple as it gets. It only has 8 instructions. It's basically a Turing machine. It works on an infinite tape, and it has a write head that can write to this tape, and it can also read from the tape. It can move to the right, to the left. It can increment and decrement the current cell on the tape. Can also do some I/O operations just to make it interesting, and of course, to be Turing complete, it needs some kind of conditional. You can read the Wikipedia article on it yourself if you're interested. It's not that complicated. And the goal for today is to run this Hello World program, but not by interpreting it, but by generating an AST and then feeding that AST into LLVM. LLVM is a commonly used compiler backend that basically allows you to feed it intermediate representation, and then LLVM will optimize that intermediate representation and generate the platform-specific bytecode for it. Basically, it's super useful for building compilers quickly and efficiently, because you don't need to re-implement all the optimization and you can easily support many different architectures. It's super useful, it's super cool, and I want to try it out. And the language I'm going to be using is C++ because LLVM is built with C++. So there's good tooling for it. And I also want to learn a bit about C++ as I don't really have that much experience with it. Okay, the nice part is that the LLVM guys have already made a tutorial for how to implement a sort of basic functional language with LLVM. This is really similar to what we're going to do. I've read through the tutorial already. I link it in the description of the video, so you can check it out yourself. Yeah, so they basically go through each of the different steps. First, the language they're implementing is called Kaleidoscope. It's a very simplistic functional language. This is what a basic program looks like. So first they implement a parser for it and then an AST. They then transform that AST into intermediate representation and let LLVM do its magic. So this is the tutorial that we are going to be basing our project on. And I think that's all I intended to say. Okay. So let's start by, I guess, creating a folder for the program. I'll name it Brainfuck LLVM, for lack of a better name. So let's init a Git project, and I guess we'll start by just setting up a Hello World program as a baseline to make sure our compiler toolchain and everything works. I'll call it codegen.cpp because we're going to be emitting the compiled Brainfuck program, and I don't think I'll need multiple files. I don't think it will be that much code. It will probably just be very complex code. So how does this work? Int main std cout hello world, and then return 0. Right, so if I compile this, I think I need to include, I think I'm missing a header, but let's try to include it anyways. Compile it anyways, codegen.cpp -o codegen. And then let's try to run it instantly. /codegen. Right. Okay. I think I know which header I'm missing. It's IO stream. And then I also need to link with the correct file. How does this go? I think I need to specify that I want to use C++11. And then standard lib equal libc++. Wonderful. And if we add a standard end line here, nice, very nice. Okay, So that is step one. Next, I guess we'll want a codegen.hpp just for convenience. Include that up here. Okay, then I'll want the hello world program that I want to run. Let's call it program.bf. Vim is screwing up my formatting. Oops. 1 second. Let's do it like this. Yeah, this will work. Now it's not as nicely formatted anymore, but I guess I can even add the formatting back in. One line. All of this needs to be indented. Nice. So, is that already a valid program? So this part is ignored because of the brackets. This part is executed. And this shouldn't even be here. Okay, very cool. I think that should be it. Yeah, right. That's the entire program. Okay, then I guess we need to load it. How do I do that? CPP input stream. File stream maybe? Or maybe iStream is already correct. Basic fstream, that sounds like it's the one I'm looking for. Implements high level, blah, 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 and file-based streams that interfaces with the file-based stream buffer. Get. I want get. Oh, okay. So how do I open such a stream? I want an stdf stream, so I want probably ostream and fstream. That must be a simpler constructor for this. What do the constructors look like? All right, so I can just give it a file name. Wonderful. So std, what was it called? fstream in, and I will. The file is called program.bf. At some point we'll probably want to build a CLI interface for this, but right now it doesn't matter terribly much. And that's the character that we will iterate over. No, right, I should probably explain what I'm currently doing. So the first step is to iterate over every character of the file and ignore all the ones that aren't legal instructions. Right, because every brainfuck instruction is a single character. Okay, then some error handling, I guess. Put that up here. If not is open, std cout failed to open input file. Return 1. Negative. Okay, does this even work? Fatal error, codegen.hpp not found. Did I not save you? I didn't. Implicit instantiation of undefined. Okay, I probably need to include the IO stream and F stream headers, I guess. And that works, wonderful. So at this point we have our input file, and then I want to loop, so let's just loop infinitely. I'm not sure how the exit condition will work yet. In.get, and I want to get this, and then I guess I can std, I can just print the character for debugging. Does this work? No matching function for call to get. Okay, what did I do wrong? Oh, right. So I don't need to give it a character. So if I just don't give it a character, then I can skip that, and it should give me its own character. All right, that's wonderful. But now we're looping infinitely. So what is the value of C? How do I know that we're done? It's not good bit. What's good bit? End of file bit. Specifies the stream state flag. Okay, so there's a bitmap, and I guess we need to check. I'm sure there's a nicer way to do this. Actually, let's just find out if there's a nicer way to do this. CPP iterate over characters file, because I imagine there's some nice API with the shift operator. I'm not trying to go line by line. I'm trying to go character by character. Oh, right. That's a lot simpler. It's an F stream. I already have an F stream. Actually, let's maybe use namespace standard, just so I can get rid of this. Okay. So I guess I can do C, and then while F stream. Does this work? Unexpected type. Right, it's in, not F stream. They did it in the other order, so I guess let's try that one. Wonderful. Technically, we are now skipping white spaces and new lines. That's not a problem for us because white space and new lines are meaningless. In Brainfuck at least. But maybe I don't want that. Maybe. Actually, let's just not worry about it for now. Okay, so now I guess I want some kind of switch in here that checks whether the character is a character we know, a valid brainfuck instruction, or it's some other thing. So how does a CPP switch work? Wonderful, that's quite simple. Switch C. So if it is a plus, case plus, break. I guess we'll continue a few of these. So we have a plus as a character and a shift operator in either direction, a dot and a comma, and then the brackets. And then is it case default or is it just default? It's just default. So that's default. Ignore all unknown characters. And then just measure break here as well. Okay. Let's check that that still compiles. It does. Let's also remove that world statement. That's not really necessary. Okay. Now let's try and build an AST. So I guess we're going to need a class called AST node. And then I guess every AST node should maybe have actually I guess the default AST node doesn't really need to have anything. And at some point we might want to do we might want to put a source code annotation in there somewhere if we want to emit fancy error messages. But that's not really necessary right now. Okay, so then we want a class, I guess just one AST node for each instruction, I guess. So an increment node, which inherits from AST node. All right, I know why we need that class. Okay, I guess we want a decrement node as well. This is kind of overcomplicated, but I do want to try and build a nice looking AST, just because it's easier to learn things that way. I mean, obviously we don't need different AST nodes for an increment and a decrement node because those are almost certainly the same thing. Then I guess we want a move left and a move right node. Move left node. Move right node. And of course these don't even have children. Put char node, that's not sure which operator that is. Actually, let's maybe just for clarity write down which operators those are. Okay, so which one was put character and which one was read character? Comma was read character. Okay. And then there's I guess let's call it group. Right, the groups should be a single node, because those are actually probably the single most complicated AST node. Conditional group node, maybe. Conditional group. Okay, and these will have children. And that would be a vector. it will be a std vector of AST node. Children. Right. And then all of these need a constructor. And I guess if we want to construct an AST node, then we do have to do I want to construct all the children at once? Do I want to? Man, I'm feeling like such a noob. It's just because I'm working in a programming language that I barely know C++. Okay, let's worry about that later. So I guess we want... Alright, we need some sort of a root scope node. And the root node also has children. But the code gen for the two is different, so we can't group them together. So let's go root node. Equal new root node. I think C++ should give us a default constructor. And then we'll probably get the add child, and the add child method should actually, let's just make this public. Don't think I need to worry about visibility for now. Okay, and then I need a constructor, root node. Equals, how do I get an empty std vector? Std vector. Can I just do this? As expected, compile errors, expected semicolons after class. Yeah, fair point. I do need those. It's kind of hard to reason about things if you don't know the language. Redefinition of move right node. We don't have two move right nodes. That's a lie. In 27 and 19. Who's redefining move right node? Oh, right. This shouldn't be put char node. It should be read char. No viable conversion from root node pointer to root node. That is because this should of course be a pointer. Fine, that compiles again. Can I get the reference somehow? Let's worry about all of that later. Okay, so now I want to append the child. Of course, these should all be pointers as well. AST node pointer. Children. Okay, how do I append to a vector? Push back. Push back. and I want to append a new increment node. Is that how you do it? Cannot cast increment node to its private base class. That should be public. Anyone who actually knows C++ is probably laughing at me right now. But I usually code in Rust, so I'm not too used to object-oriented code. Okay, so that's how you do that. Let's add a decrement node. And a move left node. And a move right node. And a put char node. And a read char node. Did I call it read char or get char? I did call it read char. I think the C function is called get char though. Get char. Yeah, so I should probably call it get char. Because these functions are pretty much just going to link with the C++ standard library, those two. Okay, so hopefully that still compiles. Okay. Now on to the more difficult part. Now I need some recursion. Oh, I can do this really nicely. Yeah, I can make a scope node, a class scope node. Nicely is a very relative term here, but it's object oriented, so it has to be good, right? Scope node. And then you can inherit from scope node. You don't need to have any children anymore. And the constructor can also go on the scope node directly. Alright, and then I don't even need the root node anymore. This can just be a conditional group node. Wonderful. And then the conditional group node just needs to override the codegen method that we will add at some point later. Okay, so now I want to create a scope node here. Scope node. And I guess each of these nodes should have a parse method, which takes should they have a parse method? Yeah. So each should have a node pointer try parse method, and they need if I do it like this, I don't need to include the header twice. They need to get an F stream. Does that work? I mean, it doesn't compile because the function isn't implemented, but still. Oh, right. This also needs to use names space standard. C++ requires a type specifier for all declarations. That is because this should be a scope. Okay, And then let's make this abstract, so nothing compiles anymore. Virtual, right, I forgot. Try parse is not virtual. Oh, it should probably be virtual. And now nothing compiles anymore because they all need to be virtual. No, wait, the way I'm doing it right now doesn't even make sense. This should basically contain this code here. And then just return. Is that not how you do it? I haven't used Vim in a while, but I'm too lazy to properly set up an editor now, so let's just do it like this, the old-fashioned way. And then I also don't need these ugly breaks anymore. Like I said, haven't used them in a while, so I'm kind of clunky. So I don't need these. Okay. And I guess let's just for debugging return a get char node by default. Who cares? Use of unknown identifier C. That is because okay, I don't know how to resolve this right now, so I'll just not put this method in there and instead put it in here. Oh, I do know how to resolve it. AST node. Oh, I think this is how you do it. And then in here I can do virtual AST node pointer parse fstream. Right. Not right. Use of undeclared identifier C. So I guess chassis, and then if not into C, then we want to return null, because everyone knows that returning null is always good. And then this should work, I guess. It does not. That's the null pointer. Is it capitalized? It is. Use of undeclared identifier in, that's because this should, it's a name. And that works, wonderful. I mean, it's not actually being called right now, but okay. Okay, so now let's parse the AST by calling scope node try parse. It's AST node. AST node pointer. AST. I guess the correct term would be to build the AST. And we try to from there, and then if root is null, or I think the cool C++ guys use if not root. Let's just output an error, failed to parse AST. Wonderful. Right, but I don't want to just parse a single one. I want to parse as many as possible. So right, a scope node should override the parser here. So a scope node needs to override this. I think I can mark it with the override keyword. And then AST node pointer scope node. So when we try to parse a scope node, then we want to start with an empty vector. AST node pointer children equals the empty vector, and then once again need each character, and then while we have a character in the input stream. Oh, no, that's incorrect. We want to repeatedly parse AST nodes, right? I think there's some nice syntax to do this. In Python, it's the walrus operator. Maybe I can find it in C++ using that. Operator equivalent. Yeah, right. That's the exact thing that I want. Does essentially the same thing. While node equals okay, so while we can successfully parse a node, we want to push that node to the std vector. Children.push back. And then once we're done, we want to initialize the scope node. Scope. New scope node with the children. And then I can make a constructor. Oh wait, right, I did do it that way. Yeah, I guess that's fine. I can I guess it might be a bit cleaner to have this private. This is private, this is public. And then we have a scope node, and we want to initialize the children to children, and the constructors takes a stud vector, or just a vector rather. Children, and initializes it like this. Does this work? It doesn't, not even close. Call to non-static member function without, it should be static. It should be very static. Why can I not use virtual and static? I mean, that has to be possible, right? The function doesn't need an object to operate on. Oh, right. In that case, it wouldn't be stored in a vtable if C++ uses vtables at all. So I guess that should work. And maybe the compiler is also choking on this. Only virtual members can be marked as override. I do hope this works. I mean, I have to be able to override static methods, right? Unexpected type fstream, of course. I keep messing that one up as well. Wait, where did I mess it up? Try parse is private. You should not be private. We are in code channel 15. Of course, you are called in. Call to implicitly deleted copy constructor of fstream. So I guess I just want to take a reference in here and in all of these functions and not actually move it. Guess that would make sense. Reference to an fstream here. Non-const L value reference cannot bind to a temporary. Can I skip that? Surely. Okay. Wonderful. I guess we should get some sort of debug representation. Actually, first let's worry about the more complicated nodes. Okay, so if we are trying to parse an AST node and we are encountering a closing brace. A closing bracket. Then that is a parse error unless we are already inside one. First, let's worry about the upper one. I guess in this case we just try to parse a scope node or a group node. Did I call it? Conditional group node. Conditional group node. Try parse from in. Okay, but what happens if we encounter a closing one? In this case, I guess we want to, if if we return null, it would look to the outside like we have reached the end of the file. Which I guess isn't terrible. Yeah, let's just return null. This does have a disadvantage because it means, I think it means that if we have a if our code ends with an opening bracket, that will be parsed as just being like an empty group. Or if we have some stuff in here even, the last closing bracket will always be implicit, but I don't really care about that for now. Don't continue parsing. Okay. Then I guess let's try and make some sort of debug representation for each AST node. So that would be a void debug print. Takes no arguments and is virtual, of course. And then a print override. And you should then just print to standard cout. Maybe, I guess we can just serialize the program again, just to make sure that it's working fine. So you are going to do that, you can do that. All of these nodes are very simple. It's very cool. There's probably some easy way to do this, with templates probably. Wait, these shouldn't all be commas. So let's do this. A decrement should be a minus. And a scope node should for each, wait, where are the two new lines here? A scope node should just for auto children call child.debug print. And the conditional group node should pretty much do the same thing, except it should also lock its own brackets. And then should I maybe add some sort of new line? Nah, it doesn't matter for now. I can make it prettier later. I just want to make sure that parsing works and I can test that on a simple program. Okay, then let's try calling the root debug print. As a pointer, did you mean to use? Yes, of course I did. Child is a private member of scope node. But surely I can use my own children, right? Oh, right. This needs to be protected. Because of course the conditional group node needs to know about itself. Why are all of you commas? Well, this isn't great. Let's maybe test it on a simpler file. Program.bf, copy, and then test some really simple file like dots inside of brackets. So it works, but we're not seeing the brackets. Wait, did I even... let's just log some debug info. Parsing scope. Right, we're only parsing a single scope node. But why does the conditional group node not override that? That's my question. I mean, if I do conditional group node, then we shouldn't parse this. Wait, why are we parsing two scope nodes now? Let's also log which character we're currently on. Okay. So why is this fine, but the scope node doesn't work? Apparently it does. Did I call AST node parse previously? I mean, it doesn't really matter to me. Either way, something is wrong because I am not seeing these brackets in here in the output. Wait, I can just use cout just for nicer printing. Okay, so we have a scope node. Maybe try logging the number of children that we found. Children dot. What's the length? I want the number of elements. Erase, pushback, putback. Size, number of elements. Ah, that's a function, not a property. Okay, cool. I guess it's probably private. Okay, so that does seem to be correct, but why is the debug print for the conditional group node not being called? Who's doing that? I guess we're printing a scope node 2 times. Scope node. Right, we do that 2 times. So why does this declaration not override that declaration? Am I misusing the override keyword? Override specifier specifies that a virtual function overrides another virtual function. I still don't understand why the conditional group node debug print is not being called. Because this one is not virtual. So why is it not giving me a compiler error for that? Oh, never mind, still doesn't work. Do you also need to be virtual? Everyone can be virtual, and it still doesn't work. Now I'm kind of confused. Oh, wait. There is no conditional group try. Wait, no, there is a conditional group try pass. It's this one down here. Oh, but that one returns a scope node. So this the pass on the right on the left, it's correct. That isn't a conditional group node. It's a scope node. So I guess we need to override the function here as well. And all of this can be public. So we need a conditional. I mean, I'm sure there's a much nicer way to do this, because this is quite hacky. It's a lot of code duplication. I assume you could use templates or something. Probably. Or macros or whatever. But I'm not going to bother with that for now. Wait, does it just work like this? No matching constructor for conditional group node. Fair point. Does this work? Children does not name a... Okay, but then at this point, why even inherit? I mean, I'm sure there's a way to inherit constructors. There is constructor inheritance using. Okay, and what's explicit? Just googling keywords here. CPP explicit. Specifies that a constructor is explicit. That means it cannot be used for explicit conversion. Okay. I guess I should mark my stuff as explicit. I guess it doesn't hurt to mark it as explicit. Explicit. Using scope node. Does this work? Yeah, now it works. Wonderful. And can I make all my constructors? I don't have any other constructors that I could make explicit. That's kind of sad. I was just happy that I could I learned a new thing. Okay, wonderful. So now we also don't need this reading character anymore. Okay, so now this is where the actual fun begins. Let's move copy back to program.bf. And then let's run this again. Wait, why are there so many commas? Does it just contain that many commas? No, it doesn't. Or does it? So why are we seeing so many comma characters? Oh, right. Right, because yeah, because I should loop it around here. While true. Because I want to ignore all characters that I don't understand. So I just loop infinitely, and that should fix that. Wonderful. Okay, that looks much more correct to me. Okay, so now is where the actually interesting part starts. This was just kind of me being an idiot and taking around an hour to implement a basic AST. Now I want to try and follow this tutorial. So we can skip right ahead to code generation with LLVM, intermediate representation. Right, so we want a virtual method on all of our AST stuff. Wait, what is... That is a destructor, I believe. So, what does that do? CPP default destructor. I'm just learning so many keywords right now. That is 3, forcing a destructor to be generated by the compiler. Why would I not do that? Of a prospective destructor. I mean, I assume that right now I'm leaking a lot of memory, right? Presumably I'm leaking all the memory. But I don't care about that. Yeah, I don't care about that. Okay, so now all of these need a... Wait, let's separate these. All of these need a virtual method that generates a value pointer. A value pointer is a single SSA assignment within LLVM. So a single statement, basically. Value pointer code gen equals 0. Okay, then we need a few global structs that are basically the state of our intermediate representation builder or whatever. Named values is all our variables that we currently have. The builder is just for constructing new stuff. Context, I'm not sure what that is, and the module, not sure what that is either. Okay. So I guess since the Brainfuck machine is operating on an infinite tape, I want to simulate that using... Yeah, I want to simulate that. Yeah, I guess I need an extra program node. Right, I need an extra node for the program, because the program node will have to do some extra setup. And then this one doesn't even need to have all of that anymore. This can all go into the program. This doesn't need to be virtual anymore because... No, actually, let's keep it like this. Okay, and you are a program node. And then this is a program node. Does this still compile? It does not. Because I introduced a bunch of stuff that doesn't exist yet, so let's comment all of that out. Semicolon after class, of course. I'm kind of confused as to why you need these semicolons after the class. Wait, that isn't the entire Brainfuck program. That's not right. What am I doing wrong? I mean, it's... What is this? It's kind of the start of something? Yeah, but then here it's closing. Oh, because I'm still pausing a scope node instead of a program node. Yeah, now it works again. Okay, so I need this. And actually let's try linking with LLVM first. Because there's a good chance that this will make trouble. Okay. -G, what does -G mean? Don't care. Okay, so we need to edit our build command a little. Let's maybe put it into a shell script. That's fine actually. Okay, and then I want to emit all of that. Let's put it there. Does this still work? No such file or directory cpp. That's because it doesn't exist. Codegen, I guess. Then can remove this one. Use of undeclared identifier LLVM context. Do I need to add a namespace? Probably. How do they do it? Well, they have a lot of code already. Oh, of course, I need to include all of the headers. Okay, so now it's complaining. Let's use namespace LLVM. Okay. that's a lot of template errors. No matching constructor of unique. Okay. Let's fix those ones below here. Actually, maybe let's not use standard like this. Wow, I just completely blew my program up apparently. Oh right, because all of these are std_f streams. And the vectors are all std vectors. Okay, and then why are you complaining about the missing semicolon? There's no semicolon missing there. Did I perhaps not include? I guess I need to include the map header. Are you happy now? You are very much not happy now. Oh, right. No matching constructor for initialization of std unique pointer, and the rest is just template stuff. Okay. Why do you not like me? What did I do differently? Oh, something cool that I can do though, and that I want to do, is put all of this in a namespace AST. Just for fun, just to use some more C++ features. So I guess now you don't work anymore. I'm just gonna do a bunch of bike shedding in here now. This really doesn't matter. But I want to make it a bit cleaner. I wish I could remember how to do search and replace in Vim. Would be really useful right about now. You are a vector of node pointers. You are also a vector of node pointers. Does that work? And then of course I still need to adjust it in the main file. So now it's AST node, AST node, AST, AST. Not sure why I'm even doing this. It's not like it's important or anything. I just feel like it's cleaner that way. Nice. And then these two are the exact same, right? Except this one is returning an AST program node. Cool. You can probably template this somehow, but I have no idea how to do it, of course. The decrement node should not inherit from noe, it should inherit from node, of course. This is all in, it's not all in HPP. St node. St. I like this though, I really do. That should be it. Yeah, now we can run again, though we are really slow because we have to link with all of LLVM and we use none of it. Okay, so now there's a problem because I can't initialize the builder like that. First of all, what is an STD unique pointer? What even is that? It's a smart pointer that owns and manages another object through a pointer and disposes of the OWL, so it takes care of allocation for me. That is very cool. However, our code is static, so does that even matter? Our objects there are static. So who cares about the allocation? The allocation is the process dying. LLVM context. So where are we actually initializing all of the stuff? Over here. And it was complaining about the context, right? No, so it's complaining about the builder. Right, because that does indeed not look like the code that I am using. Caps lock is on. That is not great. So I assume the builder is initialized somewhere else, probably. The second thing. Wait, but why is it using it like this over there? This is not valid. I mean, we have to initialize the builder somewhere, right? That's the builder. Apparently we don't need to initialize it. Cool. I mean, I don't mind that, but it is slightly weird to me, because I would assume that we have to do that. Let's not worry about that. Okay, let's start by implementing the program node. So we need a virtual cogen thing. And let's not make it actually we can no. Let's make it return null by default, just because I don't want to implement it for every class instantly. Okay, so now I want a... Wait, you don't need to be virtual anymore. You also don't need to be virtual. Okay, I want... Do you need to be virtual? You don't. Okay, I want a value pointer cogen, and I want it for the program, not for the thing up there. Okay, and first thing that I need to do is define a variable, and it needs to be mutable. Mutable variables in LLVM are kind of a pain because they don't really fit into the SSA system. And I need a variable that is basically my pointer, so the current position of the write head. Right. Okay, so basically I want to use alloc_a instances instead of value pointers. Alloc_a inst. Is that how you write it? No, the a is small, lowercase. Alloc_a inst. You are also alloc_a inst. Okay, actually let's also call the codegen methods just for fun. Codegen. Okay. Now I want to. How do I? Oh, so this is a method that will insert it at the beginning of every function. But I don't really intend to create one at the beginning of any function. Maybe it's easier to just read the code directly. All right. So I guess I do have a function. But I guess if we only have one single function, then I don't need to make it that complex. Okay, so our program node will first get a reference to the function, which will be the global function, I guess. Function pointer root. And you are override. Okay. Is that still compile? No, because I don't return anything, but that's fine for now. Okay. So and then I want to store an initial value inside the allocation. How does this work again? Value pointer is temp builder. Does create alloc_a. Okay. Some formatting changes. Mm-hmm. And then this is root. It's also root. So this is create the right head position variable. Mm-hmm. Okay, so what's the create store? All right, first of all, we load. And then create store. Okay, so how can I get a constant? How do I get a constant value? Let me open multiple tabs with these tutorials because they kind of play into each other. Okay, so how can I constant FP get AP float? Okay, what's an LLVM constant FP? What's that? A floating point value. I don't want a floating point value. I want a constant. Constant int, I guess. Yeah, I want a constant int. How do I build one? Probably similar to how I made how they make the float value. That's in this tab. Get. So there's probably a get method in here too. Operator delete. I just want a... Oh, right, it would be in here, I guess. Get... 6040. Okay, so how to get an integer type? Enum min int bits is 1. Okay. Ah, right, I can go in here and just create one. Okay. I want get doubled. Value pointer initial value is values constant int gets integer, what was it called? Integer type get the context. Guess I can find a better name for that at some point. And I want a 64-bit. Yeah, let's not care about the target architecture. I really could not care. Unless there's maybe an integer type native or something like that. Get the number of... Is there no way to get just a native integer to the... Oh, probably not. Wait, I can define a 2 to the power of 23-bit integer. Well, that's pretty nice. Why don't more languages do that? Okay, but I still need this one, and then the initial value should be 0. Right, so now I'm calling this method. And it should indeed be unsigned. And I guess a constant is also a value, I assume. Yeah, constant is a value. Wonderful. Okay, so that's the initial value. And then you should not be a... Right, you should not be a double, you should be an integer. So what's... why are there 2 different ways to build a type here? What's the LLVM type? Can I just do get int or something? Get. This should be under static methods. Get int 32 type. Oh, maybe there's a get int native here. There's not. Who cares? Okay, in that case, I'll just do a type get int 64 ty the context. And then you can maybe compile, maybe. Okay. So that's the very basic setup for the program node. Does that even work? So there's the temporary builder. The var name. Where's the var name coming from? Var name doesn't exist over there. Let's scroll down here and find out where it's coming from. Stud string. Okay, so it's just a stud string. So I do suppose I can call it like position. Surely that works. Expected expression on line 108. Why did you expect an expression? Because I put a comma over there. Non-void function, right. Segmentation fault, core dumped. I suppose I should return none. Is that causing an error? Why are we seg faulting here? Why are we seg faulting it? I assume it's because we call code gen, right? But that should do basically nothing. Oh, so maybe root is null. Cout root and line. State and line. How can I print like the literal number? If not root. So in this case, we don't have a global function. I think that might be the case. It is not, apparently. So we have a global function. Oh, it's failing in here, presumably because there's no insert block, maybe. So how do they do it in here? I mean, they basically have to do the same thing at some point, right? They have to create a sort of root function. That's the parser. But at some point they have to, oh, right here. They do that in here. Binary expression AST. AST. There has to be some root AST thing, right? Oh, here. So I guess I have to create some kind of setup code for this. Thank you, Vim. That was necessary. Let's comment this out for now. We don't need it right now. We might need it at some point. Let's call this LLVM init. LLVM init. Hopefully we don't get another segmentation fault. Who is the JIT? I don't want the JIT. I don't care about a JIT. I do not need a JIT. We still get a segmentation fault. Make unique module. Let's call it Brainfuck. Okay. I guess I should go back a few steps because presumably they have a simpler version of the code in here. Okay. And then there's the main loop. print errors. Wait, what? Where's errors coming from? So I guess we should do that at some point. But you even compile, that's very nice. Okay, but so now we run the main loop, and let's say we get a definition. Or let's say we get a top level expression. To an anonymous function. Parse top level expression. And then okay, and then we can do code gen with that. And we can print any errors. But then why do we erase it? Either way, this one is probably more important. Oh, one thing that I should probably do, completely unrelated to what I'm doing right now, is probably marking these with std_move, so the compiler can give me some errors if I try to reuse them, which I'm not going to, of course. But if I ever were to try and do that, then the compiler would give me helpful errors, I hope. Okay, but I don't really understand. I mean, the prototype AST has to have a code gen method right here. Oh, so this doesn't even like actually insert the AST for now. Okay. I'm still kind of confused why we are failing, but they are not. Okay, let's maybe go with handle definition. I assume a handle definition is a bit simpler than our. Okay, so they parse a definition, get an AST from that, do code gen on the definition AST. And okay, so let's, what does a parse definition return? Wait, I don't want you to parse a prototype. Okay, I guess let me just actually read the article for once. The context is an opaque object that owns a lot of LLVM core data structures. Yes, I noticed that. The builder is just for convenience. The module is this, that contains stuff we actually constructed, and named values is for string to value map, basically. References to variables are also quite simple using LLVM. Create f-apps between the left and the right. Okay. I kind of get that, I think. But how do you put something in the root of the program? Do I not even... Am I just being a complete idiot right now? And I don't even need to create this temporary builder. And I can just create it with my regular builder. Am I being an idiot? Perhaps. Use of undeclared identifier root. Yes, that's because you don't exist anymore. And I am still segfaulting, but now it's kind of confusing. I mean, I am calling the init LLVM method, right? I am not builder. std cout std endline. We don't have a builder. Do we not have a builder? We do have a builder. So do we not have a... Do we not have the context? Wait, are we segfaulting before this? Enter function. Printf debugging. Wonderful. So we are inside this function. Do we get to here? Of course we do. But compiling really takes a lot longer just because we're linking with LLVM. Not even using anything from them. Okay. So for some reason this causes a segmentation fault. We have a context, we have a builder. Okay, let's just look at some documentation. LLVM builder. Getting started with the LLVM system. No, I don't want to contribute. I just want to steal all of your work. LLVM IR builder, that's the one. Okay, and now I want to create alloc A. Create alloc A. Yes, and this gives us an alloc A instance. Gives also take an address space. Const twine name. Okay, does this have some more information maybe? It does in fact not. Okay, so why does it not cause a problem for them when they pass a null pointer to create alloc? The symbol table is managed at code generation by the named values map. This map currently keeps track of the LLVM value pointer that holds the double value for the named variable. In order to support implementation, we need to change this slightly so that named values holds the memory location of the variable in question. Note that this change is refactoring, changes the structure of the code, but does not by itself change the behavior of the compiler. All of these changes are isolated in the kaleidoscope generator. At this point, it only supports variables for two things, blah, 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 blah. We change, okay, this does store allocated instance. We have these. Creates an IR builder object that's pointing at the first instruction of the entry block. It then creates an allocate. For expression. Yes, that probably works because they how do I create sort of a root method? LLVM root methods, main methods, whatever. LLVM builder insert. Insert an instruction at the front. You should try to stop creating a context and build an instance each time you call create empty block. Just one context is required per thread and one builder instance. LLVM can check get insert block. Wait, am I? I think I'm even more of an idiot. Yeah, it's just I am just because I can take this into temp builder again. Create empty block. Basic block main block is basic block create with the context and the entry point. Okay, I guess let's just create a basic block pointer. What's a basic block? Basic block class reference. Okay, so Jesus Christ. This diagram is a bit too large to fit on my screen, which I don't appreciate. It's like leaking out of the documentation. Okay, the basic block is a value and it's ilist node blah 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 blah. What I am interested in is, can I use the basic block? 1 second. Can I need an address space for the block. No, wait, I don't. Basic block pointer. Okay, but can I just create the block? Can I create the block with the insert type name inst. Clear the insertion point. Get insert block. I mean, if we have an insertion block, then we should be able to get insertions, right? And then I should not need to create anything. Basic block pointer. Then let's test if we have a basic block. cout basic block std and line. No member named get entry block. I don't care about this. So if we have a block, we don't have a block. That's good to know. Okay, then I would like to create a block. Set current save instruction pointer. I want to create a block and then I want to enter that block. Create or reduce. Is there not something like a create block? Okay. I mean, this is useful, but I think what this does is it creates a temporary block. Then I can create a. Wait. 1 second. I need to understand this for a moment. Okay, so we are creating a basic block. Then we are inserting that. I don't understand that. I want to create a block with my builder. LLVM builder create block. After the other block. In LLVM hierarchy, instructions are associated with a basic block. Basic blocks are associated with a function and function with a module. Oh. That makes a surprising amount of sense. I don't even have a main function yet. Okay, set insert point is useful, I can remember that. Okay, so how do I, which you should have already declared, of course. LLVM declare main function. I mean, I have a module. Do I have a module? I do have a module. I mean, I guess I can also look in here because they. Module get function. It's too much to read for me right now. On the other hand, LLVM specifies this problem. And the LLVM module symbol. I don't want to write a just-in-time compiler, but I'm sure that's fine. Okay, do I need to create a main method? Is it different to create a main method than to create anything else? How to declare, create new function, how does declare an LLVM work, which code does LLVM? I mean, there's gotta be something that makes LLVM know, hey, this is a main method, run this first, whatever. I mean, at some point, there has to be like an entry point being declared. The first line creates a new basic. Well, that is useful. The first line creates a new basic block named entry, which is inserted into the function. Do I have the function? No. I need the function. Module get function proto get name. If not the function, then okay. this. If module get function returns null, then no previous version exists, so we'll code gen one from the prototype. In either way, we want to assert that the function is empty, in other words, it doesn't have a body yet. And then we can create a basic block, which is our entry point, and can set the insert point to that. So that is something that I will need. Either way, do I want to? I guess I want to create that in the scope node, in the program node, of course. Point the builder to the start of the main function. Now first I need to create a main function. So there's some kind of prototype code gen that presumably creates functions in here. Code gen. That's the function AST, that's the prototype AST. Okay. My main function should not take any arguments, but I still don't understand how does their code work, because at some point these need to have a main function, right? They don't. Okay, but still, maybe there's a tutorial in here. Modules, make LLVM module, pass manager, don't want the pass manager. But I need to declare entry point. I think one thing that's what's the entry point file with LLVM and Clang? I don't want Clang, I just want LLVM. But I mean, how do I tell LLVM to please? I mean, I need to create a root function, right? And then LLVM, how to define the entry point to binary. Getting started with the okay. The LLVM API, yes, I know that much. Okay, this is the basic block, I don't care about that. But perhaps I can find, perhaps the builder has some main page. Where's the other main accounts? Okay, apparently this is not it. Then perhaps the module. I kind of don't want to override this. And main function is the function containing the block. Okay, but how do I create? That's the main block, right? Where am I initializing the builder? There it is. Okay. how can I create a function like main function? For example, I want to create an empty function like void main foo. First, create a function type, which defines the function return type and the type of each of its arguments. Later for calling the function. Oh, so it's just legit completely normal function, and LLVM doesn't take care of that, and I probably need to do it later with a linker. That's okay. I can live with that. Set up main function. Type don't need all of these namespace things. Wait, I don't need you after all, because I'm using the LLVM namespace. Okay. Function pointer main, and you are the LLVM function main type. Function create from the main type. Global value, that's the name, and I want to create it in this module. Wonderful. Okay, and then you could please go into main. Okay, so at this point, we should now have a basic block. We use of undeclared identifier builder, of course you should be. It's kind of ridiculous to call it the builder. Let's just call it like context builder module main values context module builder context. You should. Oh, that's a keyword. Not. Maybe capitalized. Guess modulus. No, it's not. Okay, let's undo all of that and let's keep it. Let's keep the names as they are in the tutorial. Wait, but it is still no. It's not the builder. It's just builder. Okay, that's kind of confusing, but who cares? Okay. Are you still complaining that you can't? No member found get void. Did you mean to use? Yeah, I guess it's technically a pointer. Cool. Function create does not work. Let's look at what that would look like. LLVM function. I kind of liked oxygen, to be honest. When I first saw it, I thought this just visually looked like garbage, but it's pretty okay, to be honest. Okay, Okay, I want create, so that's static, so it should be somewhere under the static functions. Static public function. Okay, we have a function type, we have a linkage type, we have a name, and we have a module. So where's the problem? Okay, let's go through them one by one. Candidate function of while, no known conversion from unique module to LLVM module, because I need to dereference you. Is that not correct? I emitted LLVM and then I segfaulted. Oh, but that's really cool. That's like seriously cool. I emitted some LLVM, and look, I even stored the 0 in there. I mean, I assume that's what this code does, and it would suck if it wasn't. Okay, and then what do I want to return in here? I guess I'm kind of doing it differently than the kaleidoscope tutorial, because my code gen should really, I don't care about the log_a instance. Should I maybe care? No, I don't need to care. Right. Instead, what, first of all, I can remove all of this. It's just junk now. And I wonder, can I just I'm not even using this anymore. Well, do you still work? Work is a relative term here. Okay, and before we worry about the rest, let's first find out where we are segfaulting exactly. Because I feel like we're segfaulting here. Wait, what? How are we segfaulting after here? Maybe I need to close the F stream or something. I assume I can do that. I assume there's a close method in here. Yeah, close. Okay, I don't need this anymore. Okay, also in close. Be a good boy and close the stream, but I don't think that's it. I'm not sure where we are crashing, because I saw the module print, right? Malloc corrupted top size. What in the world is going on here? Someone writing to some... Okay, so I assume I'm doing some pointer garbage at some point. then I don't understand why we are able to print the generated. Oh, I guess why not. Okay, who is corrupting my stack size? Corrupt the top size. So it's a program node. Okay. So why does this kill everything? I assume if I don't do this, then does this still work? Malloc corrupted top size. Okay, why is that? Who is trying to malloc? That is so weird. I mean, I'm legit just creating a function. And even weirder is that it like worked for a bit and then suddenly stopped working. Maybe because I'm not freeing all of my stuff. I'm basically not freeing anything right now. I mean, that could be it, but I doubt it. So what does corrupted top size even mean? Okay, so I'm overwriting some dogshit memory. Okay, I'm trying to access memory that was not allocated. Okay, that explains something, I guess. So who is trying to access memory that wasn't allocated? Who's being an idiot here? Where's the LLVM function? Function create. What's a twine? So if I skip the... What happens if I don't do this? Okay. I mean, the main thing that confuses me right now is just that it so consistently crashes, and it didn't do that before, and I don't know what I changed. Once the insertion point has been set up and the named values map populated, we call the codegen method on the root expression of the function. If no error happens, this emits code to compute the expression in the deliver entry block and returns the value that was computed. Okay, driver changes. I don't understand this. I guess now is maybe a good time to rewrite the codegen method, because the way that I do codegen is different from the way they do codegen in the tutorial. Because mostly the codegen methods should just write their stuff directly into the builder, and then I don't really care what else they do. So these should all return void, I think. And who knows, maybe that fixes the issue. I highly doubt that it will. But who knows, miracles do happen. Virtual function codegen. Why do you have a void pointer? Because I'm being an idiot and I didn't remove the star, the asterisk. Corrupted top size. Who is corrupting my top size? How dare you? I did not allow you to do this. I'm just so confused as to why this is suddenly happening, because it worked for like a bit, right? I mean, I did get some stuff in here. And then suddenly we went from bad to worse. Did that cause the corrupted top size? Wait, what? Is that that's just flaky, right? I just got unlucky. There's no way. But it's not like the AST program node keeps track of the in-stream. Doesn't care at all. And then if I do close it, then we get the malloc corrupted top size. In this case, I shall not close it. But we still segfault. Which is very confusing to me. First of all, let's try to find out what the module print even does. I think I have the modules stuff somewhere open here. Basic block, that's the builder, that's the type. I do not. LLVM module. Drop trivially dead constant arrays. Print. It's the outstream. That's the dump it. I'm so confused. Why do we segfault? Perhaps because I've commented this out. Maybe I shouldn't do that. That doesn't really seem to change anything. So I guess something about our module isn't quite right. I guess when we are, we're not, are we seg faulting if I don't dump the module? Then we are also seg faulting because, but when are we seg faulting? I mean, previously we have dumped the module and now we're just returning, aren't we? Before dump. And then bit pointless right now because the actual dumping is. How can I seg fault? So what if I do fstream.close in here? I mean, perhaps I'm leaking memory a bit too aggressively. Still don't understand why we get a different error if I close it in here. Because now we get this corrupted top size, and I assume we get it in the code gen, right? Yeah. So somewhere in the code gen stuff is going terribly wrong. End line. Let's just find out where exactly this is happening. Are we seeing the 3 ones? Wait, we are inside the function type get. But it should do like nothing. Okay, let's look at that. Yes. Function type. Get. I have a type and isVarArg. What's an isVarArg? isVarArg. What does it mean to be vararg? What is a vararg? Don't want to close this one. And I find the correct function for the identifier. Okay, so presumably vararg is just something that I don't need to worry about. In that case, surely it's not the type pointer return types builder get void tie. Surely that's not it. I mean, that can't be it. add another one of these here. I feel like there's a smarter way to debug this, but I'm a high-level programmer, I'm an idiot. I'm allowed to... Okay, it's not it. I mean, I say high-level programmer, but I mean Rust. I'm used to memory-safe languages that don't just apparently die. What? Function type, get. We get a pointer. Definition. Does it not take me to the correct line? It does. It's the primary way of constructing a function type. Okay, but why does this fail? So apparently this is accessing memory that it's not supposed to. So perhaps I messed something up with initializing the builder, and the builder is just being an idiot. LLVM builder function create malloc. I mean, none of these have any references to the stuff that's from the IO stream, right? So I don't even understand why it makes a difference whether I close this or I don't. I mean, it's segfaults either way, but where? And it's LLVM IR code. I feel like I am doing something terribly stupid here, not gonna lie. But I have no idea what it could be. Because, I mean, I'm obviously leaking like the AST node here. But I don't care about that. Perhaps I should. CPP destructor. Which includes program termination. Those contract list. Oh wait, do I not? If I don't use mute, does it put the entire thing on a stack? Really stupid question. because I mean, I don't think I need to put all of these on the stack, on the heap. There's not really any point. Oh, I'm probably dying in a destructor, right? Am I dying in a destructor? Let's ignore this for now. This is probably not really related. But instead, how would I find out where I'm dying? Clang, generate, trace. Nah, probably not, because the process is immediately killed. Let's just run it again. Okay, and then let's GDB investigate core dump. It's time to bring out GDB, I think. Where's the core dump? Actually, let's just do it like this. Run. Okay. pthread kill.c. nptl. Wait, no such file or directory. I mean, something is dying, I'm just not entirely sure what it is. Maybe it is because of my standard library stuff. What if I just didn't use standard? I mean, at this point, it's not really useful either way. I need standard, I need the F-stream. Perhaps this is my fault. I mean, they also use standard. Do I perhaps not... mean, I think at this point it's safe to say that it's somehow related to standard. Fstream is just not found anymore. Very cool, thanks. Okay, so I guess I do need C++ 11. Okay. I mean, I guess we're all in this together. Let's learn something. GDB list. Backtrace. That was exactly what I was looking for. Okay, so we are in pthread kill. In nptl. Wait, we are in the codegen method. All right, of course we're in the codegen method. Okay, so we are in function type get. Then this is some liblvm stuff. I don't have LLVM with debug symbols. Either way, we are in malloc. And then we are in pthread kill. So we are being killed by malloc, print error. So LLVM is mallocing something. And that apparently breaks our shit. I guess we can try to rewrite parts of the code and hope that, I mean, it's obviously my fault at some point, right? This must be something that I'm doing wrong. I'm assuming that LLVM is not just bugged. I think that's a reasonable assumption to make. But then my problem is that I'm not really doing anything terribly stupid, I think. I mean, this does all seem pretty reasonable, to be honest. I think it's the same that they had in their code generation setup. Yeah, they did have this in here. This just links to the documentation, okay. Where's the parser? I want the code gen stuff. Right, this is the same stuff that I have. Except that I am declaring the module after the builder, but I mean that's not going to make a difference. Yep, that's the exact stuff that I have in there as well. That's like literally the make the module which holds all the code. Nope. Don't want to go into GDB again. Such a weird error too. If I don't close the stream, then we run until the end, right? And then the segmentation falls. So what happens if I load this into GDB now? GDB cogen. Run backtrace. So now we are dying inside of a constructor. Oh, we are deleting the LLVM module. So we are inside the destructor. Right, here. We are inside the destructor for the LLVM module, and this is somehow dying. Because presumably I've messed something up about the module. But what? And why is it only triggered if I don't close the in-stream? There's obviously something wrong here. Panicking in a constructor. So what is everything that they are ever doing with this module? They're really not doing a whole lot with it, and I'm doing all of that too. This STD make unique the context. Let's look at the code that I'm generating again very carefully. So I'm creating a function with a given type for the given module. Then I'm creating a block for the function, setting the insert point to that. And then I'm doing some LOK stuff. Does it change anything if I don't do that? Absolutely not, except now we have less noise, which I guess is something. Wait, what? I'm getting a double free even if I'm not doing any code at all. What in the hell? I am like legit confused now. Because it's saying that I'm double freeing something, meanwhile I'm not freeing anything. Time for GDB. Run. Backtrace. Okay, again we are in preset kill, of course, and again we're being killed by malloc, and we're inside the destructor of the module. What? LLVM module destructor double free. Oh. So I assume it is my fault because I don't have a proper constructor, destructor. Okay, so what is a default destructor? What is the default destructor? You can't make a default keyword and then not explain to me what default keyword does. Overload resolution is performed among the class with empty argument list. I don't care about that. If no user declared, the structure is provided for a class type, the compiler will always declare the structure with no. Okay, let's just I mean, we only need to care about the scope node, right? Does this fix anything? Does not at all. Let's just try delete children. Invalid use of non-static data member children, but of course it's not static. How would I delete a static variable? Rule of 3. This sounds like something smart. Destructor. cpp create destructor for class with vector. I mean, I'm sure I'm not the first person, yeah, to have this exact problem. Why are they type defing a vector? It's like the least useful thing I've ever seen. So now it's telling me that I don't need to worry about that. What happens if I move program.pf, copy? Okay, so now we have an empty file for the program. Do we still crash? We do indeed. So it is completely unrelated to anything with our classes, because now we just don't allocate at all. Actually, we do. We do allocate this. But I mean, since CodeGen doesn't do anything, I suppose I can comment out this one as well. Yeah. And now I can also get rid of this one. And now if it's still bugged, then I'm officially just innocent. Completely innocent. Yep. My stuff is not related to this at all. I mean, LLVM probably can't save that. Okay, now why, what am I doing wrong? It must be something obvious at this point. So let's think about this. Initialize module, main loop. Actually, maybe I should just quickly try and see if I can even compile this. Yes, maybe use VS Code because pasting is kind of a pain. I trust the authors. Kaleidoscope.cpp. Kaleidoscope. CSert. Am I using LLVM with the wrong file? With the wrong C++ version? LLVM 14. But I mean, I would assume that I'd get some kind of build error if that was the case. CPP version. Standard C++ 14 code. So I do need C++ 14. Let's maybe go in there. Does that fix anything? It does fixes absolutely nothing. Standard equals C++. Okay, so why am I not getting the CAssert file? Why do they have that and I don't? Clang doesn't see basic headers. That is selected GCC 12. Let's just install random shit until it works, I guess. Wait, it's actually changed something. That's like the... I did not expect that to work at all. How do I kill it? There we go. Please work for me as well. No, it does not. Did I just link to a wrong standard library? Oh, I'm going. I hate myself. But I assume that... No, I did include the header, so it should still work. Wonderful. Oh, thank God. I was like really about to just ask someone else for help. Someone who actually knows C++ maybe and knows how to figure out these problems. Okay, wonderful. Now we just slowly but surely need to re-enable all the stuff that I commented out. Man, that was not fun to debug at all. Please don't return. Just anticipating that I was having 2 bugs and just only seeing one, and now I get the other. I would just throw the entire thing. Okay. At this point, we also need to toy kaleidoscope, move copy to program.bf. Is that correct now? That does look correct. And now let's run sh. And we get a store and we don't panic, and oh my God, that feels good. Hallelujah. Wonderful. So now we need to create an array. And I've heard that that is quite complicated in LLVM. So looking forward to it. Yeah. Allocate the main, allocate the position of the right head. Allocate the tape storage. Okay, but something I did see earlier was that they helpfully linked some stuff on how to use arrays. Arrays, structs, vectors, etc. Once you add types, you can start extending the type system in all sorts of interesting ways. Simple arrays are very easy and are quite useful for many different applications. Adding them is mostly an exercise in learning how the LLVM get element pointer works. It's so nifty and unconventional. It has its own FAQ. Promising. Okay. Okay. I think I remember there was some link about a constant array. Maybe that was earlier. LLVM constant array. Then I think from the constant array you were able to look at, like, if we don't want a variable constant array, obviously. Base class for aggregate functions. Okay, I don't want a constant. Don't want an instruction, don't want an operator. That's not exactly promising. LLVM create variable array. You can create a constant initializer list. Okay, but I don't want a constant array. I want a variable. I do not want a constant array. I want a variable array. That's why I'm kind of going to create stock arrays from elements of LLVM. Well, today I discovered the LC March CPP tool and actually have a lot. Create the array. For what we need to type first. Okay, so there's an LLVM array type. That's something that we should probably construct first. Array type get, element type, and num elements. Cool. Type pointer tape type equal array type get. And then this should be a type get int 8 type within the context. And then num elements should be x 40,000. It's just something that I've just made up, and that's how big the array is going to be now. Okay. Second step. LLVM allocate instance. Okay, so the second part is actually pretty similar to what we already had. Wait, is create okay. So it's the tape, and this is the tape type, and then I'll likely want to initialize it with zeros, I guess, right? Tape, and this is then the position. Zwei, 6, 2, 6, 2. Oh, that's size. Okay. Can I say that? Can I specify that it's an unsigned integer? Probably not how you do it, right? Would like an I would like an LLVM type, because I do want unsigned integer types. Get. There's a right. Get in 32 pointer type. I don't want a pointer. I just want LLVM unsigned integer. I mean, they must have. LLVM does not. You don't have to use these types. Between signed, so both will be lowered to I32. Large IR upload and was detrimental to some optimizations, so it was dropped. I guess that makes sense. Yep, that actually makes a lot of sense. Okay, now I would like to initialize this array with zeros. Perhaps the nice person talks about this as well. We need to integers, read the get element pointer manual to know. Constant int get AP and okay, stupid question. How do I iterate in LLVM? Wait, there must be a way to initialize the entire array. LLVM initialize entire array with same value. Get integer value. What is garray? Uh-huh. I'm confused. Oh, he didn't pinpoint. He's on master. Oh my god, so it's probably completely different. Set initializer. Wait, you should not be a value pointer. You should be an alloc a pointer, no? I think you should. Okay, first of all, alloc a, did you mean... What's the type? Alloc a instock, oh, of course. Alloc a inst. And you are also an alloc a inst. And then I don't care about the signedness of the integer anymore. Right. Okay, what's the type of the garray? It's a constant array, right? Either way, LLVM alloc a inst. Do you have a set initializer method? Get align, set align. Set initializer. Oh, can I set that on any LLVM value? Because that would be great. Where's the LLVM value? Give me the LLVM value. There it is. I want set initialize. I'm not promising, there's only one of these. Dump, get type, get context, has name, get name, set name, replace all users with. Materialized, use begin. Okay, maybe I can figure out how to properly do this later. And then let's worry about the other nodes for now, because I think I've taken like 2.5 hours probably just, maybe not that, well, actually, maybe about 2.5 hours for just this little bit of code, which is quite annoying. Okay, let's call the quotient on each child. .r for each child. For auto child in the children child.quotient. And now the increment node should also have a quotient method. And it should modify the node at that position. Actually, then in that case, maybe let's start with the move left and move right things, because those are a lot simpler. At least I assume they're a lot simpler, because I'm gonna be honest, I'm not in the mood to do another really big change for now. Next var. Oh, that's quite simple. I just need so we have the current value. Wait, first I need to get the allocation. Allocate inst pointer allocated value. Var is the named values of position. And then we have the var itself. And we're trying to load the position. This is the next position. Okay. I think the naming scheme in C++ is kind of weird. Because you have these variable names that start with uppercase letters. I'm not used to that at all. Looks really weird to me. And I guess I just need another. Yeah, I just need another value. I need. In this case, we want to move left, so that's -1. Actually, I don't need to create f_add, I need some kind of normal add. LLVM builder. I want to create add. Wait, am I in the wrong? Huh? Where are the create methods at? Create. There we go. Create add, left hand side, right hand side. Okay. NSV. Not sure what NSW is. But I can just do create add, and I want to add the current value like this. This is the next value, or rather this is the new value. This is to add. Okay, and I want to get -1. And this should hopefully compile. It does not. Because my children are pointers. Alright, I also need to store these in the map. Name values. CP STD map. I need to insert a value into the map. Insert. Wait, why does it want me to insert a single value? Okay, so I can just insert it like this. Named values of position is equal to position. Named values of tape is equal to tape. Then let's put that up here. Very cool. And then let's get line 63. We're missing a semicolon here. Missing a semicolon. No, we're not missing a semicolon here. Overridden virtual functions here. Missing override. That's correct. Okay, so we have next position. Okay, so that is the code gen for move left. Now we can also do the code gen for move right. It's the exact same thing, except now we're here. Can I add a comment with the builder maybe, so the this remains a bit more readable? LLVM builder add comment. Probably not, right? Where's the builder? There it is. Comment. No. I guess it's not really necessary either way. This is really cool. Making some really good progress here. Okay, either way, I think I'm going to call it a day now. I think we've made some pretty impressive progress here. And I'll continue working on this tomorrow. I'm not sure if I'll upload this as a single video right now or if I'll make 2 videos out of it. Either way, we'll see, I guess. Yeah, let's hope all goes well tomorrow, and I'll see you later. Okay, well, I've thought a bit more about how to do things in the meantime. And I think I thought of a way to initialize the tape array. So if you recall, we initialized the position variable by just creating a store with a constant value. And I think that might work with more complex types like arrays too. Seems like it's worth a shot at least. That's what I'm going to try first. Why is the file been changed? Yes. Okay. Allocate tape storage. Okay, but now we don't want to initialize it with a constant integer, but with a constant array. So how can I create a constant array? LLVM constant array. Not constant class, constant array. Static. How do I create one? Get. Oh, right. It's up right here. Okay, so we need an array type and an array ref with a constant value inside. Let's first vary about the array type. I guess that's the same as the type that we used up here, actually. Okay, so what's an array ref? Represents a constant reference to an array. Wait, what? But I don't have a reference, that's the entire point. LLVM create constant array. Value. Okay, but I don't want to create a vector of values. That's just a huge waste of memory. That's the same page that I just saw yesterday. Right, that's what I have. Okay, that's where I just was, right, yeah. Where's the set initializer coming from? Problem is that the code he's linking here is outdated because he didn't link a specific commit. So right now I'm just makes it constant array. Oh, maybe it's still here. constant aggregate 0. What's that? LLVM constant aggregate 0, all 0 aggregate value. So, okay. It's just some struct or array, some aggregate value. That's all zeros, I guess. That's fair. So can I do something like constant pointer initial tape equals that, and then that's the tape type. And then I store that initial tape inside the tape. Store 0 initializer. I think that's about right. Okay, now I want to try out this set initializer function, because that also looks fun. Let's try tape set initializer, and I want to initialize it with the initial tape. Let's comment out this one. Okay, just doesn't exist, so presumably that was too much. Initial tape. And set a tape, and now I should have the good IR again. Yeah, we're initializing the tape with zeros. Wonderful. Okay. Let's maybe make the size of the tape generic. Tape size. So let me limit it to 4,000 for now. What's an unsigned integer in C++? Null pointer. Oh, so it's literally just unsigned int, not unit. Wonderful. Okay, still works. Still works fine. Okay, then let's try and implement the increment and decrement nodes. Those are probably harder than the move left and move right nodes, but they're definitely easier than the bracket nodes, because those actually have conditional values. Okay, now I need to modify an array, and presumably that's, I heard that's quite difficult in LLVM. Modify array. Okay, I don't want to create it. There was a link at the very end of the tutorial. Get element pointer. Introduction. This document seeks to dispel the mystery and confusion surrounding LLVM's get element pointer instructions. Once a developer gets down to coding with LLVM. Here we lay out the sources of confusion and show that the GEP instruction is actually quite simple. Okay. That doesn't answer my question though. LLVM modifier array. How to assign an array element. Right, we have the alloc_inst, right? And oh, I can create a GEP. How can I possibly turn 2 by 132 pointer into an I32 pointer when creating a store? You have a pointer to an object like struct or an array. You want a pointer to one element. Picture a string, a C string in memory. You don't have number times I8. You just have an I8 pointer. If you had a pointer to a number by 8, you'd be stepping into that array and getting a pointer to one of its elements. But with a C string, you have a pointer to a single I8 element, and you step over it, advancing your pointer by size of point t. Jesus Christ, just show me the actual code. I mean, let's just look at the LLVM builder documentation, I guess. Create GEP. That's in builder base code. Yeah, there we go. Oh, there's a create inbounds GEP. I might prefer that. Like what? Actually, let's not worry about that. Okay, so we need a type. In this case, the type is the type of the array. A value pointer, which presumably is the value where we want to load the element from. A list of indices. But why an array ref of value pointers? Let's not worry about that. He only uses three arguments. Why are there? Oh, because the other ones are default. Okay, let's try that out then. We have builder create GEP. Yeah, that was what it's called. Var get allocated type. Var. I want to load the. No, var in this context is the position. I want the tape. Tape, get allocated tape. Tape. Position value. Maybe just position, because that is also a value pointer, right? And it does want an array ref of value pointers. Load tape value at position. Okay, so that is the initial load. And I assume that is also an LLK instance pointer. Tape value. Let's format this a bit, because the line is getting quite long. Okay, and then I want to add 1 to that. I want to add that. Actually, this might just be a value pointer. I don't care. No, actually, it does need to be an LLK. Never mind, because I want to update it, right? Okay, so the new value is the create add of the tape value, and to add new tape value. And then I want to store that new value inside the tape value. Or let's call it the tape cell. I think that makes it clearer. Okay. Does that still compile? Probably not. Use of undeclared identifier create GP. That's because this should be an arrow. No member named create GP in LLVM IR builder. I highly doubt that. There it is. Oh, it's a capital C. I forget. Cannot initialize a variable of type LLVM LLK_inst from an R value of type value pointer. So it is a value pointer, but then I can't update it, right? Wait, I can. Load tape cell at position, get element pointer. There. New tape value is add that. I think that looks correct to me. I mean, I can't read LLVM IR really, but it looks fine to me. Is there some way to add formatting to the intermediate representation? Okay, probably not. So that is the increment node. The decrement node is essentially the same thing, but we add -1 instead of 1. Okay, that still compiles. Wonderful. And now I need the, alright, the put character node. This is slightly difficult because for those two nodes we need to reference external functions like putchar and getchar from the C standard library, from libc I mean. And I'm not quite sure how I can do that yet. LLVM to reference external function. Create global string pointer. Yes, that is exactly what I want. No, I don't want to load it at runtime. External functions. Oh, I can just function create external linkage. Also, that's quite simple. Okay, that's really cool. Okay, so I suppose we need to initialize these inside the program node. Declare get jar and put jar methods. These methods, one of them takes nothing, the other one takes a character. Then let's create the jar method first. Type pointer put jar, and this goes in here. Okay. Okay, so didn't I create a void type up here somewhere? Oh, right, I did create a function here. That's quite cool. Okay, but how does this work? Because I don't want to create and export a putchar function. I want to link to it. Let's look at the function create documentation. LLVM function create. Need the static members again. Linkage types, linkage. So what is the linkage? the linkage types. Externally visible function, that's not what I want. Available for inspection but not emission. Keep one copy of the function we're linking. Okay, so that's not really what I want. Keep one copy. For linking. Linking to external functions. That is I already saw that one. I have a function defined in another CPP file which I would like to use in LLVM IR. That is exactly what I want. I've done the following. We have a function type, and but he also uses external linkage and called it as well. Should probably do this as well. Let's create an intermediary variable here. G++, if you want to. When you make the for current module get function, LLVM looks up to see if there's already a function declared with this name. If the return type of null indicates that the existing IR did not declare this function, in contrast to printf, which has been declared. Instead, you want to ask LLVM to get or insert the function you need. By insert, you mean add a declaration for the function. This call requires the complete type information for the function being inserted. Of course it does. As I happen to have some code that basically does this for pthread create. Right. And this is a Stack Overflow answer that I read yesterday. I remember this. So I guess I don't do this in here then, and I instead do it inside of the putchar node. Putchar method function. That's the function type though. Get void. Oh, okay, I think I get it now. Function pointer putchar is the module get or insert function putchar and putchar type. Okay, Okay, and now put char should take a character as an argument. By the way, what does the false here mean? No, it's false for him as well, so I suppose it's fine. Okay, and now I want a character type. How did I get the? All right, so probably with the type element, type class. LLVM type. Do I just get the U8? Yeah, probably. Get int 8 type, yeah. Type get int 8 type from context. Returns void single character argument and then false. Okay, and then I want to read the value of the tape at current, get the current position. That's already difficult enough. Read the cell value at the current position. Tape. No. Allocate instance pointer is named values tape. And then now I have a value pointer. And then I want to call the putchar function with the value type. LLVM create function call. This looks interesting. They use both for function bodies and external function declarations. Wonderful. Function, you should get a declaration. How to call a function in LLVM. Call instruction create. I feel like this is something that the builder should be able to handle. Call instruction. No. create call. I don't want to call BR instruction, or I don't know what that is. Oh, create call. I have a function type, I have the function pointer itself, I have the arguments, and the name. Okay, that's cool. That's builder create call with the putchar type, putchar, and the arguments, which is just the current, which is the tape cell. I should rename those to be less confusing. Position bar. And then I can also give it a label. Yes, I can. Call putchar. Does this work? No member named get or insert function. That is because I have a pointer. Create call. Did I forget the arrow? Ah yes, I messed up the arrow again. Wonderful. LLVM. No viable conversion from LLVM function callee. Okay. No matching number for create call. Right, we do want a value pointer. So what does module get or insert function give us? LLVM module. Looks up the specified function and then it gives us a function callee. For a function type plus callee pointer pair, which can be passed around as a single entity. But I need just a callee. Get callee. Does this work? Type to derived class pointer function type. I need a function type pointer. That's fair. Fair enough. Okay, wonderful. Call void putchar. Yeah, that looks about right. And now I just do the same thing for get character, just slightly different because of course we don't read, we write. So this thing should return a character, and it takes as an argument the void type. And then this is the getChar function. getChar, getChar, getChar type. And then we want to call that. Okay, and I assume create call gives us a call instruction pointer and a call instruction. Okay, but how do I get the result of that call? And I'm sure they have that in the tutorial, right? That's like very basic. Call it. Okay. But where do we actually call these functions? I mean, at some point there needs to be a call. The call to a function type get creates a function type that should be used for given prototypes, since our function creates a vector of. And they called it. Call expression AST coach, and that sounds like it's correct. Builder create call. Right, and okay, apparently that gives us a value pointer, but LLVM says it doesn't give us a value pointer. Fair. Either way, value pointer C, and then I want to store the value inside the table. Store character in tape cell. Actually, I guess the builder is the one that actually stores stuff. Create store. But create store does not take a name. Everything else has a name. Why does create store not have a name? Okay. Then let's store the C inside the tape cell. Member reference base type int is not a structure or a union. Oh, get char. And this is also this is the get char type. And we call get char. Use of undeclared identifier tape cell. Right, that's because I don't have any arguments. I'm kind of suspicious. I don't think it's working right now. But who am I to judge? Let's try implementing the scope node. Or rather the conditional group node. And then we can also make this one up here pure virtual. Okay, so the first thing we need to do is let's actually look up how these work again, because I kind of forgot. Let's get the English version so you guys can read it as well. If the byte at the data pointer is 0, then instead of moving the instruction pointer forward to the next command, jump it forward to the command after the matching closing brace command. Okay, so first I guess we should maybe I mean, we need to increment the instruction pointer first of all. Wait, no, we don't have an instruction pointer. Yeah, right, we're compiling. We don't have an instruction pointer. Okay. But I need some kind of label. So I can create a go-to or whatever. I don't want a name. A branch target. Okay, how do they... I think Kaleidoscope does at some point get ifs or whatever. Or at least some kind of conditional stuff. So let's see how they do it. Control flow. If then else. AST expressions, of course. Create f compare 1. We emit the expression for the condition, then compare that value to 0 to get a truth value. As a 1-bit value. Sorry. Create blocks for the then and else cases. Insert the then block at the end of the function. This code creates the basic blocks that are related to the if then else statement. So in our case, we only want if else, so only 2 branches. Note that it passes the function to the constructor for the then block. This causes the constructor to automatically insert the new block into the end of the specified function. The other 2 blocks are created but aren't yet inserted into the function. Right. Okay, I guess first we need to first step is loading the current value and comparing it to 0. That is, no matter what we do, that is the first thing that must happen. No, I want the cell value at the current position. Check if the cell value is 0. That is what the instruction should do, right? If the byte at the data pointer is 0, then instead of moving the instruction pointer forward to the next command, jump it forward to the command after the matching close and brace commands. So now we want a create compare 1. Builder, please help me. Need documentation. LLVM IR builder. Create. No, right, it's all inside this one. Create comp. So what does this comp wonder do? Oh wow, it doesn't even tell me. I guess I just want a simple create compare. LLVM compare to integers. There's an I compare instruction. Create I compare. But what's a predicate? Oh, here, there we go. True if I want true if equal. I want I compare equal. Right. Builder create I compare. Spell compare. And then I want I CMP underscore equal. With the tape cell and a constant value of 0. I think our tape is made of, yeah, it's made of bytes. So that's the conditional, and then I want a few basic blocks, namely I want an if and a then block. And we should have an insert block because we have a main function. Yeah, we are inside the main function, so we can create a block in here. Then else. Okay, and the then block is immediately inserted. Okay, fair enough. Is 0 and it is not 0. Is 0. It's not 0. Okay, and then we want to create a conditional whatever. Create a conditional BR cont true destination false destination. Okay, that's exactly what I want. Create cont BR. The condition is, I guess, this one. Yeah, and that's a cont v. What does the builder expect it to be? A value pointer. Let's format this a little. And then the condition is 0, is not 0. Okay. And then I guess I want to build the blocks. What's the merge BB? If cont. Once the blocks are created, we can emit the conditional branch that chooses between them. Note that creating new blocks does not implicitly affect the IR builder, so it's still inserting into the block that the condition went into. Also note that it is creating a branch for the then block and the else block, even though the else block isn't inserted into the function yet. This is all okay. It is the standard way that LLVM supports forward references. Okay, with the value 0, jump forward to the end of the AST. Build up set insert point is 0. Okay, and now I need some kind of go-to. LLVM go-to. GCC compiler supports a useful value labels, values, extension, which code address of Okay. LLVM insert label. Oh, is a basic block already a label? Oh. Oh, I get it now. So a basic block is basically just a label. Okay, so I guess I want a basic block for the, yeah, right. Mark the start of the code. This makes it possible to later return to here. Conditional group start, and we create a basic block. It's called group start, and then we want to immediately set the insert point to this, to the conditional group start. Everything else should go into here. Okay, and then at the very end, we also want to mark the end of the, oh, right, mark the end of the code. Note that this block isn't immediately inserted, it's a forward reference. Okay, and that means that I do have to take this one out. And I I guess we can declare jump targets. Yeah. This is let's call it group end, not conditional group start. Group start and group start. Okay. Then that is the group end. Okay. And then if it is 0, then we want to jump to the group end. And if it is not 0, then we want to continue as we did right now. Is not 0. If the value is not 0, continue, we simply emit all the child IR. So that is what we're going to do here. And then once we have emitted all the child IR, exit condition, check if the current tape cell is 0. If so, jump back to the start block. So once again, we need to position var didn't change, but the position changed. Tape didn't change, but the tape cell changed. Yeah, let's move these up here to the start of the function just to make it clear. Value pointer position tape cell. And then I can use them like this, which also makes it a little more convenient. Entry condition, check if the current tape cell is 0. If so, jump past the end of the group. So get the current position, check if the value is 0. And then if the value is not 0, we simply emit IR for each child. And then we need another condition, so this is the start condition. Then we also need the end condition. Right, and if that is 0, if it is 0, then we want to jump back to the group start. And if it is not 0, then I guess we want to First, let's insert the end block. Oh, the function end. That sounds interesting. Because I'm looking for a way to jump to the end of the current function without creating another basic block. That's an iterator. Okay. And then I want to insert the group end block here. And that can just immediately exit, I guess. Don't need to write, and I think it can just be an empty block, because that an empty block should be a label. And if it, yeah, right. Okay. I think that could work, and that would mean that we have now implemented everything. But first, let's see if it even compiles, and then we can worry about debugging everything. Use of undeclared identifier ICMP equal, no variable overloaded. Okay, so first of all, how do I get ICMP equal? ICMP equal. I compare instruction. I assume that's in some header that I'm not importing. Predicates. All the possible instructions. Okay, but which header is this in? I guess I want to create iCompare equal. Yeah, that's probably more reasonable. Create iCompare equal, not WQ equal. And then where's the other? There's the other comparison. iCompare equal. Expected expression, because there is a comma here and there should not be. I assume it's the same problem for group end. Oh, this should be group end. Never mind then. No matching constructor for initialization. Okay, I guess let's not do this. No member named insert an LLVM function. But I didn't make this up. I think I got this from the tutorial. The function insert. That is literally what I have. What? Mm-hmm. Inserts the basic block list at position. But that is exactly what I'm calling. Oh, do I need a function? No, I have a function pointer. What? No member named insert an error function, but there is such a member. Huh? The function. I mean, I have like literally the exact same code that they have. Creates basic logs that are related. I'm so confused. Why does this not work? I mean, I had the documentation for function open somewhere in here, right? Function. There's the insert. And there's the end. And I'm calling this one, but I can't call this one. I guess I could technically even insert it beforehand, because all of this is inside the all of the code in here is inside the group start. So I guess it wouldn't even matter, and I could put it here. And that would hopefully compile. Assertion get operand, get type. Both operands to ICMP instructions are not of the same type. Okay, ICMP equal. There's the tape cell. Could it tell me what the types are? Okay, maybe I'm misusing the GP instruction. Create GP. Probably just using it wrong. But this should all be int 8, right? Okay, can I get the type? std cout tape cell dot tape cell get allocated type. Strict end line. Can I print it like this? They use get type apparently. And then the constant int. And then this one is apparently a different type. It is, and I assume I can skip all of that. Okay. So for whatever reason, my tape cell is not the correct type. LLVM load value from array. Accessing elements in LLVM. Create extract value. What? I assumed I was passing an array of 2 doubles to the jitted function when in fact it was a pointer to an array with 2 values. Create extract value. Extract value. Pointer to the location. Oh. So get element pointer tape cell address, and then the value pointer tape cell would be a builder create load with the I'm sure there's a I mean, I know that it's an int 8 type. And I want to load it from the tape cell address. And tape 7. Mm-hmm. Okay, and now you should not die anymore. And I assume I have to change that in multiple places, because why do we get a segmentation fault now? Maybe because I have to not overwrite them. This doesn't compile, right? I can't shadow variables like this. Let's create a helper function for that. Static value pointer get current tape value. And that should do that, and then this is a value pointer. Get the address cell value at the current position. And then I want to return the load value. Okay, and then need these two again. You still segfault, get current tape. Oh, of course, because I have to define you up there. Gotta define your functions before using them. And we still segfault. Get current tape value. Do you still segfault? No, you only segfault. Okay. GDB. Code. Run. Backtracks. Okay, so we're trying to get the module of a basic block, but there is no module for a basic block. Okay, we are inside the code gen for the get character node. We are creating a load. We are at line 190. And we are trying to load the position. Do I need to maybe reset the inside position? Yeah, maybe just reset it to the global function. Try that. Candidate function viable. LLVM function iterator. So what is the parent? Return the enclosing method or null if none. Okay. And I'm not able to get like an end block from here. And back. I want the back. Okay, GDB codegen. Are we still in the same place? Yeah. No, we're not in the same place. No, right, we are. Never mind. Never mind. Okay. So we are trying to generate the intermediate representation for our children. Yeah, right. We are inside a program node, inside the conditional node, inside the get character node. And for whatever reason, the get character node does not deal particularly well with being inside create node, create. Okay, but why can I not call that? Why does create load now suddenly fail? It shouldn't, right? I mean, if I create load in here, do I panic in there? Let's just avoid any naming conflicts. GDB codegen run metrics. Right, so now I can reproduce the error in here. So the create load for some reason fails. But why? So this load fails. Okay, then I guess let's look at the builder. Create load. Maybe there's some annotation in here. No. That should be correct. Okay, what does create BR do? Oh, it's just a branch. Sorry about that. Okay. So why do they branch? Oh. Let's look at what their syntax actually looks like. Oh, so they explicitly merge the two blocks together again. I should do that too. Okay, let's quickly create a helper file to see what the conditions should look like. Okay, so there should be sort of a start block, and that start block this is difficult. In the start block, I need one block to execute the actual IR and one block to sort of quit and jump to end. And just let me understand this for a moment. Start inserting into the then block. Strictly speaking, this call moves the insertion point to be at the end of the specified block. However, since the then block is empty, it also starts inserting at the beginning of the block. Once the insertion point is set, we recursively cogen the then expression from the AST to finish off the then block. We create an unconditional branch to the merge block. One interesting and very important aspect of the LLVM IR is that it requires all basics blocks to be terminated with the control flow instruction. That would be the verifier will emit an error. I suppose we could call that an error. It's a very liberal interpretation of the word, but I guess this could be seen as an error. Can I? Hello? Okay. Coaching then. Okay, so I guess we don't really need the start block. No, we do need the start block. And the way we terminate the start block is by... Wait, but how do they terminate the merge PP then? Adds the merge block to the function object. Check and changes the insertion points that the newly created code will go into the merge block. Create a PHI node. Okay. Okay, for a moment, let's forget about the exit condition. And let's only worry about generating or not generating the start code. Okay, so first of all, there's the start group, which right now we don't need. But I do need I want to understand what a PHI node is. To implement the sigma node in the SSA graph. Style of LLVM code. Do they... I mean, I'm sure they explain the PHI node a little. Oh, yeah, they do here. Now that we have parsing and building the AST, the final piece is adding LLVM code generation support. This is the most interesting part of the if and else chapter because this is where we start to introduce new concepts. All of the code above has been thoroughly described in previous chapters. Simple example, blah blah blah. If you visualize, It's fairly simple. The entry block evaluates the conditional expression x and compares the result to 0. If you're not familiar, let us say the Wikipedia article is a good introduction. There are various other introductions available from one of your favorite search engine. The third version is that the execution of the VIA operation involves remembering which block control came from. Oh. There are two sorts of values that float around in code written for your imperative. For now, just believe me that you don't need SSA construction to handle the case. For number 2, you have the choice of using the technique that we described. Okay. So, what is the else? Okay, let's forget all of this for now. So we need an is0 and an is not 0 block, and we also need a merge block. And the is not 0 is the one that we actually want to insert into the function. Okay. So wait, is not 0 is the one that we want to insert into the function. Is 0 is more difficult. Okay. So the is not 0 block is basically this is difficult because of the way I did code gen. Add incoming. So I guess the code gen should return values after all. Because I kind of need the combination of all the different values now. Jump down to the code gen. I mean, the function body can be any number of statements, right? So how can I concatenate all of them together? Okay, I think I'm going to have to take another quick break. I think I'll continue maybe in a few hours. Okay, later. Okay, I guess one thing that I could always try is just, for now, only worry about the first condition. So only the entry condition. And I guess if the value is 0, then we don't want to do anything actually. But if it is, then we want to do that. Okay, let's first remember the basic block that we are currently in. Because that is what we will eventually need to return to, right? Base block is the builder get insert block. And then this is the base block get parent. Okay. And then I guess actually we want to compare if it is not equal. So that would be create I compare something. I compare not equal. Let's make sure that this is really what I expect it to be. So if it is not 0, is not 0, then we have this branch. It's not inserted for now. And if it is 0, then we want to basically not do anything. And instead, yeah, I guess that would be the same as the merge block in the if then else of the kaleidoscope example. Okay, now the main problem is that my blocks don't have such a simple return value system as the kaleidoscope values. Basically, I don't have return statements at all. There's no value that is being passed around. So let's look at LLVM node. Add incoming. I don't need to load the position here. And then we want to jump to the merge block. Explicitly pull through out of the branch. Great. To merge. Okay, so now we have our wait, no. Yeah, now I can insert the function insert. First I want the is not 0. The function is not 0. And then next I want the merge block. And I assume that's not going to run because we don't have these fine nodes. Alright, LLVM function insert doesn't work. Can I maybe just create it in here instantly? So first the is not 0 branch and then the merge branch. That actually worked surprisingly well. Let's once again move the Brainfuck program to a temporary value and then maybe echo plus, no, just a single plus into program.pf. Run that again. Okay, so this is all set up. And that does indeed look good. We previously had some problems if I did some more complex stuff in here. Does that still compile? It does. Break. That does look kind of fine. I kind of want to compile this now to see if it actually kind of works. Because I suspect that there are quite a lot of bugs in the in the intermediate representation as well, as rather in the one that we are emitting currently. So let's try and get it to build at least. Right, we need a function path manager. Thank you, Vim. Unique pointer that points to a legacy. Does that still compile? Let's look at the entire code. Do they have any headers that we don't, maybe? Yeah, they have quite a lot of headers that we don't. So all of these we're missing. I mean, I don't want a just-in-time compiler. A legacy path manager .h. In IR. I guess it makes sense that it's in IR. Let's find out which header this function is in. Transforms instruction combine. One of the ones that they have down here. Yeah, they do. Nice. So now we have a path manager, and now how do I actually apply it? It is attached to the module. Once the path manager is set up, use a series of add calls to add a bunch of LLVM paths. In this case, we chose to add 4 optimization paths. Once the path manager is set up, we need to make use of it. We do this by running after our new. Okay, and we probably want to run that in codegen.cpp. So this should be a domain. Verify function with name. Okay. Okay, so now I need to make this actually create something. Actually return the function pointer. Return and this will fail because now inheritance is just broken. Okay, but most of these methods don't actually return anything, right? I mean, I can just have it, the program can, I mean, it's not pretty, but I could make it so that this one has an attribute like function pointer main, which is initially null, and then this could be void, and then this main is main. Or isn't there a way to get a function? The module get function main. I could do that, I guess. Yeah. I can make it so that the program node defines the main function, and we assume that main function now exists in the module. Function pointer main is where sketcher. the module get function. What type does main have? Let's just call it main. Get function. Do I even need this? I don't think so. Missing a semicolon. And now we segfault again. Not due to the conditional stuff that I added? It is not. Is that due to verify function? I guess I should check where it is we're panicking. GP. So that is the function pass manager. That is dying on me. And I guess if I don't optimize, then there won't be a problem. Indeed, there's not. Okay. How do I generate the code? I mean, we don't have to optimize for now. How do I compile it to native code though? Compiling to object files. LLVM doesn't require us to link in all the target functionality. So let's also do this in LLVM init. And then let's make the So we are also not going to allow any kind of customization. You can either live with the target that you get, or you can not do anything. CPU is generic. Target specific feature. Specific CPU. Okay. I guess I can pretty much just copy all of this. Legacy pass manager pass. Okay, I guess I want to factor this into another function at some point. Let's try it out, I guess. Okay, seems like this changed a bit since the tutorial was written. Get default target triple. So, does this function still exist? If so, where? Or do I need to include other headers, maybe? Yeah, I do. LLVM target parser host stage. Okay, then ignore that header for now. I guess that's maybe just a typo. Okay, so get default target triple. Default as default. Terminating and setting host. That's from 2016. want to surely I'm not the first person to stumble upon this error. LLVM version is 14. Is that a macro? Do I have that macro? I do, but now we get a segmentation fault. We are inside the optimizer. Okay. It passes to init file. Let's just create a method. Static int target, and then we can pass the default triple. And now, what data type is the target triple? Let's look at target registry. Oh, so it's legit just a string ref. Okay. And return 0 down here, because that means that everything went fine. If not equal to 0, fail to commit. Of course, init for target must be defined before all of that. Oh, it does want a std string. Okay, fair enough, then that's what you get. Target triple. Target triple. And let's also lock the target triple. Okay, so we are emitting something for x86, 64, PC, Linux, GNU. That does sound about right. What does not sound about right is the segmentation fault. And I assume it's also going to segfault inside the FPM. GDB. Run and backtrace. Yeah, I'm inside the FPM run. So it's trying to run the instruction combining pass. But program.bf right now is just a simple plus, right? Yeah. Into program.bf. Suppose it will still crash. But why? We are creating a basic block inside the main function. Is maybe the tape incorrect? Does not need the tape. Does it need the children? segmentation fault. Is it the position? Okay. Run backtrace. Is still inside the function manager. Okay. Well, we're messing something up. LLVM, IR, minimal pixel. LLVM generates simple IR. How old is this tutorial? It looks really old. Mapping high-level constructs to LLVM IR. I just want to figure out why my stuff is crashing. A simple project that uses LLVM to generate IR code. I mean, I'm not even like doing anything. CPP, LLVM, declare simple. Main function. just create a declaration for it. Right. Mm-hmm. So I have an empty main block for the main function. So why do we seg false? I mean, it doesn't really get much simpler than this, right? I want to see if their example even works. Yeah, let's see if their example even works. Because if it doesn't, then something major is wrong. Something about my toolchain. There we go. Okay, then let's change the one.sh script to instead build kaleidoscope.cpp. A few adjustments need to apparently be made. Equals. Let's just try around a bit. Okay, and now the weird thing is that I don't understand why function insert doesn't exist. I mean, we are on 17. Okay, I guess perhaps I should be on 17 too. How can I change the version? LLVM update. Or rather, how to install LLVM 17. Okay, I think I'll do this, but it's probably going to take a while. So I'll pause the recording and I'll be back once I have set up LLVM. Okay, luckily I was able to fix the error rather quickly. I did end up trying to build LLVM, but failed due to lack of memory. But luckily the error was really quite simple. I just forgot to return a value from the function. And it turns out that LLVM really doesn't like it if you don't return a value from a function. And you can see here we segfault, and then if I just return void, and this verify function is just a sanity check, then we no longer segfault, and we successfully built the output.o file, as you can see here. That's a test file from earlier. So we have the output.o file, which is an object file, and if we display the contents of that, then we can see that it does indeed have a main symbol. Okay, now the next step is to actually turn this object file into a executable file by linking it. And in our case, there might be a simpler way to do this, because of course we don't really need to link anything. We already have a main function. But I have no idea how to do it in another way, to be honest. So I'm just going to link it. So we need to build script and then want clang plus plus cogen. No, output.o. And we want to link that into main. And that should be the build script then. Run sh. And it does absolutely nothing, as I would expect. And by the way, one really interesting thing you can see here, I currently don't, I think what does the program look like right now? Program.bf. Yeah, it's just a single plus, so it really does nothing. And this is the LLVM IR before it's being optimized, and you can see that it is indeed allocating the position variable and the tape, and then it's modifying the tape. But in the optimized IR, which you can see down here, it's just a return void, because all of these things don't have side effects, so they can safely be ignored. I think that's really cool. It shows that our optimizer is in fact working. But of course, I would like to have a slightly more complicated program, maybe. Do I still have the copy? Did I call the old program? Yeah, let's move the copy back into program.bf. Let's try to run that again. We get a segmentation fault. Okay, so let's look at this step by step. We have these outer functions, and the main function, which is really huge. Where does it even start? Oh, right, we're probably dying in the optimizer. So this is all the unoptimized IR, which is also why we're seeing the same operation so much. Okay, I assume that's due to the getChar and putChar methods, because those are rather hand-wavy and I didn't really know how to link with external functions. I did see, however, that somewhere down here they had something about because in the example they also have a few external methods like cosine and sine. Yeah, right here. So how do they do that? Okay, but at what point do they get imported into the LLVM stuff? Called up. I mean, I guess we can try just copying this. At some point I should really merge the header and the code gen into a single file, just for clarity. External first statement. External functions that can be called by the IR. Char, what? Sure if there's even a point to defining them like this. Get char. Okay, does that help in any way? Not if you forget your semicolons. Functions that differ only in their return type cannot be overloaded. Okay, so perhaps I should change the definitions inside the code gen such that it does return an integer. Right. And then the get char what's the signature of get char by default? So does that still segfault? By the way, where does it segfault? Set LLVM, of course, inside the pass manager. To absolutely no one's surprise, I guess. Okay, and let's also make sure that it is indeed the get char nodes and put char nodes that are ruining everything. Do you still sec? Nope. Run sh. Yep, you still segfault. And you also, do you still segfault if you don't have put char? You do. Well, that is interesting. Why is there a label after the return? Okay, and I guess we should do the same thing here. Children might modify the user. Wait, what? Now that there isn't a return at all? Copy the program that they have got. Let's cut the program a little. Let's remove all of this. And then maybe also remove this. Do we still segfault? We do. So why is there no return void anymore? Why is the return void down there? Someone is doing something stupid. And I suspect that it's the scope nodes, because those are the only ones, the conditional group nodes, because those are the only ones that actually do anything interesting. So also get rid of this debug stuff. Rid of this too. Can I get rid of this? Do we maybe only need one single group and nothing else? Yes, this already segfaults, but if I delete it, then it doesn't segfault. Yeah. Okay, so the groups are just broken. 1 second. Okay. We have the position variable and the tape variable. We have a few basic blocks here. Okay, do we perhaps need one of those finals? Let's try building one of those. Control flow, if then else. Wait, is the merge block ever inserted? It is, yes, okay. Okay, so we don't need this one here anymore. And then we want to create a file node. And it should evaluate to avoid, I guess. I wonder if I really need to find out if I have a void type. Builder get void type. Okay. Get void type. And then these should be null. And we can either jump there from is not 0, or we can jump there from the base block. Does that fix anything? That should be now capitalized. V and phi node got a null value. LLVM phi node. And instruction used to select a value depending on the predecessor of the current block. It's also used as a value, which is one of the classes it's inherited from. For example, the following C function. Could either be 1 or 0 and LLVM is defined once. So we check if tuple is true and then jumped. Okay, but I don't really care about that. I don't have a value that I want to build. So do I need to add an explicit fall through? base block again. Does that maybe help? I don't think fine nodes are for me because is it looping infinitely? It shouldn't. But then what is it doing? Can I maybe explicitly fall through? The base block directly and I can skip the entire merge stuff? Perhaps? No, I can't do that. I do need the merge stuff. Merge block simply falls back into the Okay, but why does the label is not 0 end up after the return? And okay, I guess in this case it might even be fine, but we're jumping back to the entry when instead we would like to, yeah, when instead we would like to jump back to here, to the branch. Okay, I mean, this is really a simple if that I want. Simple if, just no side effects, no return value. Yes. Only allow for if and else statements. Any code preceding the if statement along with the conditional check will go into the first block. That block will then jump to either the if block or the else block based on the result of the conditional check. That is exactly what I'm doing. Finally, both the if block and the else block will jump back to an exit block which will contain any instructions following the end keyword. Oh, that means that I should not jump out of the merge block and I should not I should just stay in the merge block and then inside here I should also not go back into the main block. Hey, that compiled. And we can clearly see that the merge block contains everything after that. Wonderful, that's very cool. I think I can delete all of this. I'm just gonna, Right now we only have the forward jump and not the backwards jump. But hey, it's kind of working. Now I would really like to copy into program.pf. That probably still doesn't work, but hey, you never know. Well, I guess you do know now. Okay, so we are segfaulting. Where are we segfaulting? GDB codegen. Backtrace. Function path manager as usual. Okay, I guess let's just debug this step by step again. Still segfaults. Doesn't segfault anymore, but takes quite a while to emit the object file. Also doesn't segfault. Wait, what? Yeah, let's maybe skip linking. Doesn't really matter. It's hashtag. Okay, but we're definitely still segfaulting, which is good. Okay, is it perhaps because we have these nested invocations here? Still segfaults. That doesn't segfault anymore. Do you still segfault? That still segfaults. Okay, I assume you can delete these. I mean, anything other than the loops should really not cause an issue. But apparently it does. Can I delete you? I can. Then let's also get rid of this. Step by step. Can I get rid of you? Can I get rid of you? Okay, so it's actually completely unrelated to the loops. That's curious. Didn't think that was the case. Oh, perhaps it's because of the external functions? Because of the comma? No, it's not. Does this still segfault? Yes, it does. Then I guess let's remove all the unnecessary characters. Okay, so this doesn't segfault. Does just a minus segfault? Yes. For whatever reason, this is a segmentation fault. That is highly unexpected. But wait, the plus symbol does not segmentation fault. Okay, perhaps I'm not supposed to use negative numbers in... Where is it? In the decrement node. Perhaps there's a builder create sub method. Nope. Yes, there is a create sub method. Then let's use that instead, I guess. So, wait, that's the increment node. Never mind. I want the decrement node. To sub. And that is now a create sub. And then I guess I should do the same thing here. To sub and to sub. Do you still segfault? You still segfault. Why? It's like the exact same thing then as an add. Like literally, it's the same thing. But why are you in int 64? I'm storing int 8s in there. I mean, that shouldn't be an issue. But the tape definitely contains int 8s. I don't understand. It's also just the decrement node. Everything else just works completely fine. Create add, create sub. Do I still have the print warning somewhere in here? Yeah. What's this all about? I mean, shouldn't this give me like some, at least some very little kind of information? I mean, right now it's just printing the entire thing, no? Yeah, it is. But is there maybe something really weird about my AST. Because I can't imagine that I guess I can just do a very literal string comparison. Like I can do this and make it into good. Sorry about that. No. Let's emit standard error into good. Okay. And then let's do this and emit it into bad. Yeah, I mean, it's the exact same thing. Why is one option consistently segfaulting and the other is not? It's really the exact same thing. No difference whatsoever. And if I were to create a bug and make this an add, would it work? It would, what? That is so weird. Maybe I'm doing something fundamental wrong. I can't add -1. I mean, can I add 255? Why does this segfault? Okay, it's even. It has even optimized it out into single -1. But if this is a 1, then it works fine. That does suspiciously look like a bug in LLVM. Because that should not cause a segmentation fault. Yeah, that should not ever cause a segmentation fault. For what values does it segfault? Does it segfault for 23? $254? Does this work? Just adding 254 and then adding 1? Now I want to add 1. That is so very suspicious. That is like ridiculously suspicious. But I can't imagine that a complete idiot like me just found a bug in LLVM. There's no way. I mean, this is also like very basic stuff. Don't really know what to say, because that is ridiculous. Let's try running it on the entire thing again. Hey, we got an object file. That's pretty cool. It got optimized really weirdly though. But I mean, as long as it got optimized, I don't really care. But let's write a comment for this. Note: this seems really suspicious. If we add 255 or -1, sub1, we get a segmentation fault in the FPM. However, adding 254 and then 1 seems fine. LLVM bug. Or rather, is this a bug in? Okay, let's look at the output.o file. Has my main section, very nice. I guess then, actually maybe I don't want that inside the run script. It did nothing. It's doing a lot of move ups. Curious, why didn't this get optimized? Oh, I probably should. I think I disabled the put jar and get jar nodes. Yeah, those might be valuable to have. Just to make sure you don't suddenly segfault. Sometimes I'm really, really happy about we got something. Sometimes I'm really, really happy about Rust and like non-C++ error handling, because I gotta admit it's kind of painful to debug some random segmentation fault 3 function calls deep inside LLVM. It's just not very fun. But hey, look, the external functions actually worked. Now the only question is, why is everything a parentheses? Let's make this into a single command. Are we not initializing our memory properly? Because I mean, it should be deterministic, of course. But it's already so cool that we are seeing anything at all. Is that the correct length? I wonder. HELLO space WORLD exclamation mark. Is there a comma in there somewhere? And a new line. Okay, so it is the correct length, but the tape is not in the correct state. File output.o. I guess we want debug symbols. Oh, right, something else that let me test is, and we probably don't need all 3 in here. The problem is not that complicated. Perhaps it's faster to test. Yeah, not really. Let's keep it in there. They had a chapter on debug symbols. I would like to have those. Source level debugging that helps it just forward code to draw for the compact encoding. We keep the original source location for each instruction on the instruction. The optimization parser should keep the source locations for the link. Merged instructions only get to keep a single location. This can cause jumping around when stepping through optimized programs. Secondly, optimization can move variables in ways that are either optimized out, shared in memory with other variables, or difficult to track. First, we make our anonymous function that contains right. To remove the command line code wherever it exists. Lastly, we're going to What is clang-xir? Clang-x treats subsequent input files as having type language. Oh, that is really cool. And I guess if I pass a dash, then that means that it should come from standard out. That's really good to know. Let's see, where does this stuff end up? Yeah, I also need to get rid of all of the console stuff. But that means that we don't actually need to do this at all. Then we can just pipe this into clang-xir-. Warning, overriding the module target triple with okay, so the linker doesn't like me anymore. Why is that? Do I even need this? Does this even do anything? Let's just keep it in there, I guess. Oh no, let's difficult to say. Undefined reference to main. But we have a main. Okay, how do they emit? They only use the module print, not the module dump. So perhaps my stuff just isn't ending up with Clang. Clang-x ir-. Do it like this. But what about the module target triple? I don't have any of that. Why is it complaining about an undefined reference to main? XIR dash should be cat. Wait, this isn't even valid IR? Clang plus plus. Equals load I8. So apparently someone is doing something stupid here. Yes, let's get rid of that for now. Get current tape value. Create GP. Right, that is not correct. Or is it? But then why didn't it complain about that earlier? Load tape cell at position. LLVM load value from array. Accessing elements in LLVM array. For the first part, a good reference to LLVM is to write what you wanted in plain C and then compile it with Clang and look at the LLVM output. So what is X in this case? Okay. So his x is... no idea what the x is. I mean, what I don't understand is why I can load the stuff as an object file just fine, but not if I try to compile the actual intermediate representation. How can I do this? I mean, LLVM should not be able to emit invalid intermediate representation. I think we can all agree on that. LLVM emits invalid IR. Process of report is producing invalid LLVM IR. Andrew! This will print the following LLVM IR. However, I don't see that. So perhaps that's just something that happens from time to time, I guess. I would like to fix it though. Either way, I think I'll have to take another break. See you all later. So I did a bit more debugging on this, and I found out that the bug was really simple. Basically, the way I used the builder create GEP function in LLVM was just not correct, because in LLVM pointers don't transparently dereference. So first I have to specify that I do want the 0, the first element, so the element at index 0, that the pointer, the array pointer points to, which is of course the one array because there are no others, but I still have to specify a constant integer. And if I do that, you can see that we now get past line 12 and can compile up to line 20. So that's pretty nice. And what I thought I'd do is I would refactor all the code a little, because right now we have a lot of duplication with increment node and decrement node, etc. They basically do the same thing. So we can probably simplify that, and so that way we don't have to fix all of these errors in many different places, but instead we can fix them once and be done with it. So I have get current tape value, and then perhaps what I also need is static value pointer get current position. Yeah, that sounds reasonable. So I need the position variable, and I need to load it. And let's format that a little so it's a bit more readable. And then I can return that. And then in here I can just call get current position. Then let's refactor that. Let's reformat that a little. And hopefully once we've done these minor cleanups, then everything else will get a lot simpler. Yeah, see here it's also incorrect GEP. So perhaps what I should really do is not get current tape value, but instead get current tape cell pointer. And then I can just call value pointer tape cell equals get current tape cell pointer. And then I just noticed this function is of course wrong, because I do need to load the value first. Value pointer tape cell is builder create load. What's the syntax for create load? Wow, this is also wrong. Create load is the get allocated type, and okay, can do that. Where were we? We were here. Tape cell pointer get allocated type, and the tape cell pointer and the tape cell. And then we add to the tape cell. So let's count this, load the current value in the cell, increment the value, right back. And we want to store the new value in the want to store the new value inside the tape cell pointer. I think that's what we want to do anyways. And then I do the same thing for this. And I'm curious whether that bug we noticed earlier is still present, where we can't decrement. So let's try and compile this. 66 value pointer. And here we don't want to load, instead we just want to return the tape cell address. No member name get allocated type. What does builder create GEP return? Returns a value pointer, okay. In this case, I guess we just want a int8 type. That's what's stored in the tape. Of course, the same thing in the decrement node. Okay. And then in line 368, I have to modify this. Maybe get current tape value would still be useful. Static value pointer get static value pointer get current tape value. That would just call value pointer pointer is get current tape cell pointer, and then we just create a builder create load, and we load an int8, and we load it from the pointer. Use of undeclared identifier tape cell address 79. Of course, this one is not necessary. Don't need to assign the variable for returning it. And we're back to the old bug. Okay, so presumably someone is still creating... Wait, we didn't segfault. Cool. So perhaps that was a bug that I added at some point, who knows. Seems to be gone now. So we can get rid of this, that's pretty nice. Then we don't increment the value, we decrement the value. Still compiles. Let's also look at the IR for a bit. Okay, so presumably someone is still using create GEP incorrectly. Yes, here we are. Put jar node. So we just want value pointer tape cell is get current tape value. Store character. So who else is calling create GP? Create GP. Yeah, this one is also correct. And this one is also the one that is incorrect. Wait, why is there even a get char node in program.vf? Oh, it's never executed, but it technically exists. Okay, cool. Okay. In this case, value pointer tape cell pointer is get current tape cell pointer. And hopefully you should no longer error out. Use of undeclared identifier tape cell. 243 tape cell pointer. Stored value and pointer type do not match. Okay. Create call. Okay, so now the issue is that that get char returns an I32, but our tape can only store I8s. Let's make these comments a bit nicer. I think the code can use a lot more formatting in general. I really don't like having this many arguments all on one line. Okay, now I need to cast the variable. LLVM cast I32 to I8. Like I want to truncate it basically. Create int cast. Okay, IR builder once again. Create int cast. Why do I need a char pointer? I have a value pointer and a type pointer, so presumably the value that I want to cast and the type that I want to cast it to. What's the char pointer? Create int cast. So he's passing true, but it's expecting a char pointer, is it not? Oh, there's an override. But then what is that character pointer for? Either way, doesn't matter. I think we were erroring out. Second. I'm really formatting a lot of these arguments right now, but it's also really bothering me a lot. In get char. Yeah, right here. Truncate the value to an I8 so we can store it in the tape cell. Value pointer truncated char is builder create int cast with C. The I8 once again. So this one. I'm curious as to why this compiled as an object file before. Was it just like invalid, all of it? Should be an int 8. And it is signed. Okay, so that should fix that error. 22. Oh, of course, I need to actually use the truncated char. Truncated char. Void type only allowed for function results. So I guess I don't have to specify that it takes no arguments. Very cool, I think. What did we get here? Let's remove some of these files. rmoutput.o, because there's a lot of bullshit right here that I used for testing. ./a.outs should be the correct one. That is not what I want. So much bullshit. How many testing files did I use? Okay, a.out, what is that? It's an elf, dynamically linked. Okay. I'm kind of concerned about these methods here that are dynamically linked. I kind of want to do it like Kaleidoscope did, and I'm not sure how they did it, but they had these methods down here somewhere that could be linked. Where are they? Maybe it was in a later post. Yeah, right here. How did that work? Putchard, where is this used? These external declarations. Okay, but how do they actually run it? I wonder. Let's strace the a.out to see what it's doing. So all of that is process setup, of course. And then we have write calls. Wait, what? Backslash 375? How does that even work? HELLO. HELLO white space WORLD. Doesn't match. How do I even debug this? I guess I can also ltrace it to see if the functions are actually being called. Ltrace. And that should tell us whether getChar and putChar are even being called. Hey, they are being called. That is very cool. HELLO white space WORLD. New line. Okay, so kind of right, I guess. So I guess the only thing that's apparently something is working, right? Because we have the LL, which is mostly correct. Let's try writing a simpler program. Copy move program.pf. Copy. Let's make a backup. And then let's try writing just dot. That should print a 0. Where's the compile command? Ltrace dot/l. And we have indeed made a putChar 0. Oh, I know what's wrong. Of course, I haven't even implemented the... But that is so cool. Does that also work? Okay, so the main language works. Only problem that remains is that I did not implement the jump at the closing bracket. I only made it for the opening bracket. So I am pretty sure that that is the only thing right now that we're missing. Okay, let's clean up the code a little and remove the object file code now that we can definitely compile it with the with just Clang. Okay, and then let's also turn on the optimizer. And right now it doesn't do anything. It's really cool to see that simple programs like these work fine. That is super cool to see. Okay, now I need to figure out how we can implement the conditional group node. So right now we have the base block, which is the main function. And we have the we have the main block, the base block, that's the function that we enter from. Then we have a condition and we create two blocks, basically the is_not_0 and the merge block. The is_not_0 block executes all the code while the merge block just jumps past the end. But now we want to create a second option at the end of the is_not_0 block. At the end of the is_not_0 block, check if the current cell is 0, in which case jump back to the... I want to jump to right before the start condition. How do I do that? I guess I have to insert another block here. Yeah, let's do that. Let's create a block here that is the group start. And we insert that directly into the function, the group start. And then both of these should be... Wait, what does basic block create? What are the arguments for basic block create? LLVM basic block create. Can't type create anymore. Typed it too much in the last hours. Create. Where is the create? Create, and it needs a function pointer parent. Insert basic block pointer, insert before. Okay. I guess this should still be fine. If I insert the start block first. Okay, and the base block should simply fall through to the group start block. Okay, and at this point we have the entry condition. Does this still compile, by the way? If I have a program like, I don't know, this, doesn't matter at all. Because I don't think I changed the behavior yet. We have a segmentation fault. That is not good. Alright, I should set the insert point to group start. And then this compiles fine. Wonderful. So now we are inside the group start block. Actually, let me look at the LLVM. I guess that's a bit more understandable. I don't want to optimize it because that's going to optimize away all the interesting code. Okay, so we have the entry, then the group start where we load the position. Okay, that is very cool. And then if it is not 0, we execute all of that code. Otherwise, we jump directly to the merge. Okay, wonderful. Wonderful, wonderful, wonderful. But down here, we want to check if it is in which case jump back to the start of the group. Oh no, this is wrong. Let me look up the Brainfuck documentation for a moment. Brainfuck. Jump back to the command after the matching. Okay, I need to jump after that. So that would be the is_not_0 block. So I don't need this block at all. it's commented out instead of completely removing it in case I have making some kind of mistake. But so the end condition is that, and then I pretty much just want a conditional branch. And if it is not equal, ICMP. If it is equal, then we want to jump to the is not 0, which I should probably rename now because now it gets confusing, and otherwise we want to jump into the merge block. Does that still work? ICMP equal is not spelled like that. Very cool. Okay, so we have the is not 0, and then hey, that's very cool. Is that still valid IR? I'm kind of being paranoid now. Interesting how long Clang takes to compile this very simple IR. But I guess that's fine. Okay. Now I guess I should test it, but I'm kind of scared to. Let's first rename the is not 0 block. Let's call it group contents. Group content, not contents. Group content. Group content. And group content. Still fine? Still fine, okay. Then let's move, or rather copy into program.bf. And let's try to execute it. ltrace a.out. And we're looping infinitely. Why are we looping infinitely? If the byte at the data pointer is non-zero, oh, if it is, oh, this should be a not equal. Wait, what? Oh, I should have compiled. Okay, run sh, that goes into clang-xir- and that gets into ltrace a.out. Is that correct? Is that dream alive? Because that looks like ASCII characters. Yes! Yes, 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 yes. Oh, that is awesome. I love it. That is great. Took like what, 8 hours? 9? Yes! That is an LLVM backend for, or rather a Brainfuck frontend for LLVM. Does it work with the optimizer? Please, please don't. I mean, the optimizer is not going to break it. I believe. Oh, I loved it so much. This is great. Okay, now I guess we should clean up the code a little in various edges, and then we can try to commit it. Oh, I love this. I have to run it again, just to see it. I mean, this is just awesome. Okay, one thing that I do want to do is merge the CodeGen and the CodeGen CPP and CodeGen HPP, because those are largely equivalent. Perhaps we could create a CodeGen CPP, AST CPP, and AST HPP, because the AST is kind of separate from like the main stuff. Yeah, let's go ahead and do that. Code tabby ast.cpp and tabby ast.hpp, and then all of the AST would of course go into AST CPP. Actually, let's not overcomplicate it. I think that's unnecessary. Yeah, let's just. I mean, it's not that big of a program, is it? Yeah, it's like 300 lines. It's 400 lines. That's ridiculous. We don't need to overcomplicate that. Okay. Now I guess we can move all of that just into the main program. This goes here. Namespace standards. And yeah, all of this can just let's just put it at the top of the file, I guess. Nothing wrong with that. But I do want the main to be then at the bottom, so you can quickly find it if you're looking for it. Where's main? Main. Okay, that's main, and we no longer need to include CodeGen HPP because CodeGen HPP is empty. Does that still compile? Or did I break it? Yes. Then we can remove CodeGen.hpp. I just noticed that I didn't make any intermediary git commits. So it's all going to be one big thing. I don't really know what these do, to be honest, but I think we initialized the native stuff already, so perhaps this could just work. Without it, I mean. Yeah, didn't matter. And then perhaps we could move that initializer code up here, or I guess down here where the other initialized stuff was. Format this a little. And we can also, wait, why is this not in the header file? Yeah, I mean, if we only have one big header file, then might as well move it all in there. Where is the AST node? Oh, it's static, so we do have to do it like this. Okay. So that's fine then, still works, I guess. Very cool. Just checking to see if I have any obvious bad code in here that I can maybe fix before I commit it. But I guess I don't. Wait, this should be... don't I have to get current position? I'm not even using this variable anymore, am I? Yeah, I'm not. Am I using it in here? No, I am not. Can't just remove all of this. Nope, I'm not. Can just get rid of this. Completely unnecessary. I really like how all of the get char stuff, etc. was just working fine. Okay, I think at this point the code is nice enough that I can commit it. I mean, it's still not great, but I mean, I'm still learning C++, so leave me alone. This was really fun, and I'm really happy with the results. I don't think I ever took that long to write a hello world. Hope you enjoyed it. I definitely had fun. Hope you learned something, and I'll see you later. Bye.